let's get started. Everybody online, can you see my screen?
Yes.
Yes, I can see.
Well, so on Thursday, we started taking a look at the requirements document. And as you see it, like it's kind of, we started talking through it, different context diagram, the business processes, how the page flow works, and what are the kind of non-functional requirements and thoughts. We also talked about the architecture, right? Because when we looked through the design document, we started talking about the interior architecture that we are going to implement for this system. And we looked at it in detail in terms of what are the system architecture going to look like. We looked into the data tables, and we looked at it, what are the kind of user interfaces and external interfaces is going to look like. So let's jump a little bit more in the analysis phase. The key activity is getting the requirements. But also one of the key activity is for a quality assurance person is to put together a testing plan. A testing plan is nothing but a strategy and the detail about how you're going to test the system once the system is built. How are we going to infuse the quality into the whole process? Okay, so it'll contain a whole bunch of things that essentially determine what the process, what the standards, and what are the type of tools that one is going to use it to do that. So let's look into those things. Okay. So what we're going to look into it is main important, what are the key terms? What are the different specification documents and requirements documents are used to? Okay. So now, in the last class, we talked about the quality assurance is bigger than just the testing. But when you consider like testing is one of the keystone activity in overall quality assurance process. Okay. So let's look into why do you want to do the testing first? No, right? Your goal for testing it is essentially not to pass the system, but to identify all the errors that are present in the system. And while doing that, you are indirectly checking to see if the system meets the requirement. So if you're not able to find any error into the system that is built according to the specification, which was laid out into the system specification document, that indirectly proves that, hey, the system meets its requirement. And more importantly, if you look into the non-functional requirements, it talks about what is the operating environment in which the system should run. So if you're able to pass both functional and a non-functional requirements, you can prove it that, hey, the system works as expected and works in an operating environment in which it's desired. Okay. The third key thing is to check if the system is fit for purpose. Okay. So let's talk about an example that we talked about in the last week, the Amazon. Right? So if you have an online retail system, and if it takes you 10 minutes to find anything into them, okay, it may still work as per specification that, hey, whenever you search something, it takes a longer time, but it does. But is it fit for use? Is it something that you as a user would like to use it? Is it going to meet your goal? Right. So you always look into it as you get into more of a web-based system, is to check it, is it fit for the purpose? Is it going to meet what I'm going to look for, whether it's an operating environment or whether it's a performance and so on. Okay. Because you can like build a system that's according to the specification, but it doesn't do the way that it's expected. by the users. A lot of times you will think about it, there is a dedicated branch that has been spun up into the software development known as a user experience. If you, as a user, if your experience is bad in using that system, you're not going to look forward to use that system. So that's the testing enables you to say, hey, is it working, but is it also ready to go to prime time? Right. So another example, let's say, if you're building an automated vehicle, right, and every 5 minutes it shuts down. Right? It works as completely fully automated. You don't have to sit behind the wheel, but every 5 minutes it shuts down. Do you consider that's going to be fit for purpose? You won't, right? Same way it goes with the systems. So keep that angle in mind as you build your quality assurance aspects of testing and test plan. Okay. Now, the way you do all of the testing is through something known as a test case. Think about test case as nothing but in a scenario which you are executing against the system to perform a task. Okay. So your goal, whenever you write as a test case, is to make sure that you're able to discover an error. Right? So your intention, whenever you're running it, is to find an undiscovered error. And a successful test is the one that actually finds it. Some of the other criteria that you're going to see it is it's not a redundant. If I write 5 test cases, they all are validating and doing the exact same thing. Does it add a value? It doesn't add a value, right? For you as a quality assurance person. So you need to make sure that your test cases are complementary to each other and not redundant. Then you think about it, the complexity. So your test case or a procedure is going to contain a whole bunch of steps, right? It'll be log into the system, then do this, and then do this. So it's going to have a whole bunch of steps. A good way to gauge it whether a test is good or not is if it's very simple, then probably you've gone too far, right? And then potentially you can merge it. If your test case is like 15 pages long, then you need to seriously look at it and say, hey, did I make it too complex? Am I trying to validate too many things into one place? Okay, so later tomorrow, we'll start talking about the test cases. And throughout the next week, we will start writing the test cases, and you will be able to identify as we write that what we meant is an example of a simple versus a complex test. Okay. So, as a software tester, right? So in other words, you're going to validate and test the software at multiple times throughout the lifecycle. Right? One of the first example that you try to test it is when you read the requirements document and apply that 3C and a T rules, right? It's nothing but it's type of testing you're doing is, hey, does the system have all the information? And can I actually test the system or not? Your goal as a quality assurance person is to find the defects or a bug or a problem with the system as early as possible in the life cycle. So think about the example that we talked last week about building a house. Right? If there is an electrical wiring problem, eventually you want to find it when the design or architecture is drawn up. It says how is the wiring is getting connected in the house. Right? That will be the most ideal because it's very easy to fix that because all you have to do is just change the design. Versus if you kind of put that wiring into the wall and you figured it out a problem at that time that, hey, it's a short connection from here to here. I may have to rerun it. Why? Ideally, you should have found it earlier, but at least it's good that you find it at that stage. Now, at this point, your cost will be a little bit higher, right? Because you have to rewire things. In certain cases, if you need to get the approval from the county inspectors, then you have to call them again. So you lose some time, you incur some additional cost to do that. It's great if you find it that. If you don't find it that, and you actually find it out after the drywall and all the work is done, and then you try to turn on the switch and the light doesn't turn it on. At that point, potentially you have to rip the drywall, figure out where the issue is, and go through it again, the inspection for fixing the electrical wire and then fixing the drywall. Right? So as you can see, the later in the stage you find the problem, the more costlier it's going to be, both from financial point of view as well as from timing. Okay. Same thing, you are going to find it in the system. If something was incorrect, it's much more easier if you identified in the requirement stage. Hey, let's go fix this. There is a clarity that I needed. Great, right? You lost the time only to meet again with the user and then go ahead and get that clarity and then update the documentation. That's the cost you incur. Versus if you find it out way later in the stage when you're actually doing the testing, think about it, at that time, the software is already written, right? All of the other activity is gone in. And now if you find a bug and you have to fix it, remember, the developer has to go back, look at the code, fix it. Oh, by the way, for those major, they have to go back into the design phase and fix some of the design first. And that could have a wider impact on the other parts of the software. So the work required, it's a very hard, significantly hard. So as a software tester, you should always try to find the bug as early as possible in the lifecycle. Now, we started talking a little bit about this one on Thursday when you talked. Right? There is only two people who understands the entire application through and through. One is architect, and the other one is quality assurance person. Because they are the only one who has a complete view of application. Right? So if I may be a developer, and if this is a base system, I might be assigned to write only one component of that entire application. So I might know good in the detail within that component, but I may not have a whole understanding of it. If I think about a user, right? If I'm a dealer, I may know all the functionality about me as a dealer, but I have no idea what all things are landed as. If I'm a project manager, I probably know about the finances and the amount of effort it's done, but I don't know how the system works. The architect is the one who has built all the components, identify how the API works. So they probably have a much better view of the entire system. And the quality assurance person, as you, right, you have looked through an entire requirements document, understand where are the breaking point could be, validated it, and then you will see it as we go and start testing it. You're going to wear a different hat. You will it's log in as a dealer to test out dealer functionality. Then you will log in as a lender to test out the lender functionality. So you have a very good view of everything that works across the whole spectrum. Okay. So that's the benefit of you as a quality assurance, that you understand the whole picture. Now, what happens if you don't understand the whole picture? You may miss the parts to validate the system, right? And the system is going to potentially go into operational environment as a sub-quality system. Okay. So one of your objectives should always be is to understand the application really inside out. Okay. The other aspect is you need to have a good understanding, not just the overall system, but individual functionality also. We talked about the 5, 6 different architecture, right? Going from a monolithic all the way to mobile. And we know each one, as you add more and more components, the complexity gets added for interface for each one of them. that means there are breakpoints within the system, it's going to increase it. And then you need to understand what all are your breakpoints to figure it out. Or we'll talk about the test cases as we go through. Now let's talk about the testing lifecycle. Okay. So in the last session, we talked about the overall software development lifecycle. And we started talking that the role of quality assurance person starts very early in the lifecycle. It doesn't start at testing time, it starts at the analysis time. So if somebody says that, great, it's a software development is great, but what are you going to do as a quality assurance person? And you need to have a good understanding of this life cycle in order to come up with a strategy and plan of how you're going to test the system. Okay. So the first thing you do is you try to understand what the requirements are. Right? So you review the requirements document, you look at it, what is expected out of the system. So you need to make sure that there is a completeness and there is a correctness in those requirements. Once you have that, you start laying it out, what will be the acceptance criteria? In other words, what behavior you need to see it in the system in order to accept that it meets the requirements that you looked into. So let's say going through the same example of the wire. If I know the electrical wiring is done or not successfully, well, what kind of things I would do? Potentially, I'm going to turn on the switch to make sure is the light turns on. I'm going to probably find some sort of tester or plug, put into each one of the plug wall outlets to make sure those wall outlets, there's still active current in them. Right? So to me, my acceptance criteria is let's turn on the switch, make sure it turns on, and plug something into the wall that essentially validates that the wall outlet is working properly. Same thing in the software world. We talked about, hey, our flown agents can sign up the dealers. Well, if that is a requirement, what criteria I'm going to see it in the system in order to do it? Right? One of the criteria is, hey, I'm able to go into the system and able to successfully create a dealer. If I'm able to do that, then I know that particular requirement is fulfilled. So think of about this is the 3C aspect. This is the testability aspect. Then you go look into it as, okay, now I have all this information. What approach I'm going to do the testing? Right? How many test cases I'm going to build it? What are the priority? And what tools I'm going to use it in order to test those things, right? So I'm going to build a strategy, how I'm going to fulfill this particular thing. Then you go ahead and say, okay, I understand that what strategy I'm going to use it. Let me lay it out step-by-step instruction of what I'm going to do it, right? So I'm going to start designing those things in detail. And we will start that actual work starting later today or tomorrow. Okay. And then once I'm done with all of that and the software is ready, the conversions point comes in where it says, hey, now that I have something that I can execute against it. And when you execute it, that means you're executing against this criteria, look for it. When I run the test case, am I getting this criteria? If yes, then I'm going to say, it's okay, it meets that. If not, I'm going to find and open a bugs and says, hey, system doesn't do this, well, as a requirement specifies it. So there is an issue that you need to go ahead and fix it. So they will start identifying what all needs to be done. The developers will get involved and says, okay, let me go in and fix it. They will fix it. They will give you a new version of software that you rerun the test against it. And you keep in that cycle till it actually works. Once all of that thing is done, occasionally you go ahead and do the reviews and audits. Okay, you say, did I meet all of the requirements? Or did I meet some of the requirements? Now, is my scope when I'm reviewing it is it just a single function or the whole system? That you can identify, hey, login works, but creating a credit application functionality doesn't work. And that here is the 5 problems that creating that functionality. Right, so you work on that till the point where you just say, it's okay, everything that is required for system to become an operational is working as expected. At that point, you just create a baseline and deploy the software and says, hey, I'm ready to do that. And once it's done, it goes into the maintenance mode. Till you say, hey, I need to add additional new feature or new functionality. Then you go back to this one and keep following this. Okay, any questions? You guys understand?
Yeah, I have a question. What is the relationship between the QA and the testing?
So think about QA is a much broader activity versus testing is a narrow task within the quality assurance. Okay. So when I ask all of you to read the requirements document and do the 3C and T test or validation, that's a quality assurance activity, right? Did you run any software? No. Right? Did you test anything? You didn't. Right? So QA starts way earlier in the cycle. Now, once you write the test case and you have the systems and you actually run the test case, then that activity is testing. Right? So you can say, hey, my work scope is just to test this thing, or my work scope is to make sure everything works. Right? So you can identify, hey, before you do it, you need to follow the standard. Let's say we talked about building a house, right? The quality assurance doesn't start at like it's, hey, everything is built, let me go and test it. Let me walk on the floor, make sure it manages and holds the right amount of the weight. Right? Let me make sure the plumbing system works. Those things are actual test activity. But you have to go back before that at the architecture stage to make sure when you're laying it out things, it's laid out such a way that it will work once you start plugging into things. Right? That's a quality assurance. Because if you didn't do a proper architecture, you didn't do a proper weight load analysis, and when you build a structure, the structure may not be able to hold the weight and it falls. Right? So think of quality assurance is a continuous activity versus testing is just in a point of time activity. Okay. Any other questions? Did you get online? All right. So you're going to see the STLC model here like this. But sometimes you will also look at it as something known as a remodel. Okay. So this is nothing but similar to the SDLC, but this goes into a much more detail of how you're going to break it down your work. Okay. So if I think about this one, strategy planning in design, well, how do I do this task in detail? Think of that. So in this model, essentially on this leg of the V, you design and you build. And on this leg of the V, you validate and execute it. Okay. So let's start with it. The first thing you get at is a requirements document, right? Just like with the one that we got for the offload. Okay. If you write the test cases just based on that business requirements, right, you're testing it from the user's viewpoint, right? You're not looking any detail on how the system works. Herschel keep mentioning it on Thursday that, hey, it's a black box testing. Think of a black box testing is that I don't know anything inside how things are built. All I know it is, here is the way to give the input. Here is the way to measure output. Okay, so if perfect example is if I give you a calculator, right? You don't know internally how the calculator is calculated. Right? When you say 2 + 2, you don't know what algorithm is implemented inside the hardware and inside the chips for you to come to an answer for 2 + 2. But you can still write test cases, right? So, hey, if I do 2 + 2, expected answer should be 4. And if I run that, if I get 4, then I know it's working, right? So the test that you write it from a user's point of view that you don't know anything else, it's essentially called a user acceptance testing. So think about the acceptance criteria that we just mentioned. I have a requirement. I'm going to lay out what all of my acceptance criteria is going to be. Okay, and how I'm going to come to test those acceptance criteria. So you get the requirements, you build the user acceptance testing. Once it's done, you drop it down one level further. And so it's great, the requirements. Let me break it down into the functional components. So you look into our flow, so it's going to be broken down into 6 or 7 segments, right? Managing the dealership, managing the users, creating credit applications, generating reports. Those are nothing but the functions, right? Here are the functions. So you look at it and say, hey, if you say it's a managed dealership, what should be the test? Right? However, what test I'm going to do it to manage just the dealership. So at that point, I'm not looking at the whole system. I'm looking at a small part of the system. And I'm going to go and start getting detailed. So the test that you write it, in order to test whether the function and interworking of those functions is working as expected or not, is the system test. Think about another example, right? We talked about multi-tier. So you're going to have a business logic layer in between, and you're going to have a data tier. So can my business tier access and pull the data? And is the data that coming in is the right data or not? Right? So if I'm using a banking system, I log in and just say, hey, show me my account information. How much is balance? What is the last transaction? And when I pull it, am I getting the data correct in that order? And it's able to get the information what I'm looking for. So that's a testing between your business tier and a data tier, right? So all those things become part of a functional test. Then you look in and say, great, I know what all function needs to be done by, let's say, the managed dealer module. Well, let's go it down a further level and talk about the API or functions that each one of them is going to call, right? So they're going to break it down, this functional specification into technical specification, and says, hey, when I make a call to the database, I'm going to ask this 4 pieces of information, and each of the information is going to come in this exact order. Because if it doesn't come in that order, I don't know what the value for each one of this is going to be. So those ordering or the technical specification allows a developer to drill it down on a functional module and says, this is how each one of them is going to be. Okay. So think of, if you're a Lego fan, right? You're building the big Lego structure. You break it down, that structure, into small pieces. Okay. And then you take that each of the small pieces and says exactly how each one of them, what all components are used in order to build that small structure. And then all the way at the bottom, you see it a single Lego module, right? A single Lego piece. And if you look into that piece, it has a definitive interface, right? It connects it exact same way. If it's a 2 connector, 4 connector, 6 connector, 8 connector, right? But each individual connector still allows you to connect it. Where you can add a 2 connector with a 6 connector and build the bigger pieces. So each one of those small thing, if you convert that into software world, right? They write a program. So you may have a program which says that, hey, I'm going to generate the dealer ID or franchise number. Remember, there was a specific rule that was put it and says the franchise number needs to be unique and needs to be generated this way. So I might write a program which says, hey, given the information I have about the state and county, I'm going to write a program that generates a unique franchise number. That's all this program is going to do. Because it's part of a bigger group, which is going to start talking about managing dealership, which is part of a bigger group, which is going to be talking about the overall system. So at that level, you're going way level detail into the software code. So you build something known as unit test. But hey, I'm going to test only this piece, which is just the generation of the franchise number. Okay. So you take a requirement and keep further drilling and detailing it out. And you're going to keep detailing specific acceptance criteria or test criteria to write down the test for each one of them. And then you follow as part of it. You also write step-by-step instructions that, hey, if at this level, if I'm trying to validate the user requirement, I can say, can I create a dealership? Then go down to functional specification. Well, in order to create dealership, what all information I need? What are the required data? What is non-required data? Can I do that? What other areas where this dealership information is used? Can I invoke those things? Then you go down and says what it takes it to create a new dealer, what it takes it to update the data, what it takes to make something as an inactive dealer. Those are the small pieces that collectively made up this piece. Then you go down and just say, hey, let me just create a franchise number only. Let me talk about how I'm going to edit certain pieces of information. So the next thing developer does it is as they're drilling it down and they're ready to write the code. Now that I know the small pieces, I can start write the code and validate. Okay. So the developer will start executing. If I may want to give an analogy to all of you, right? I'm building a home. Right? I know how many rooms I needed. I know what kind of structure I wanted. Great. Once you know how many rooms, let's go one step down and says, what are the dimensions for each of the room? What is the purpose for each of the room? Is it something it's going to use as a study room versus something is going to be used as a kitchen or versus something is going to use as a bedroom? Each one is going to have a different functionality. Each one is going to require the different things in it. Then I'm going to say, okay, now I know that this room is going to be used as a kitchen. Let's talk about it. What are the appliances, how much storage it's going to be? What should be the plumbing system, right? What should be the layout is how many counters space I needed? What will be the design for that? Then you go down and say, great, I got all of that. Let's talk about the specific sink in the kitchen. What should be the design, how big the sink should be, and how it interfaces with the plumbing system in the drainage system. Okay. And then once you have all those details, then you can just order a sink and says, this sink has to be that. Then you bring the sink and you put it on the counter and integrate it with the counter, right? Integrate it with your plumbing system, integrate it with your electrical system. That's code. Then you stop it and says, okay, now is the sink working? I connected everything. Is the sink working as expected? Right? So I take that thing, whatever I kind of wrote it down, how I'm going to test that sink is working. run it and say, is it working? Yes or no? If no, it needs to be fixed. If yes, great. And what is the next thing I'm gonna do? I'm not just gonna test the sink, right? Because I'm building the whole house. I'm gonna just go ahead and start this. Okay, is the kitchen works as expected? Is the kitchen has a nice layout going in and out? Does all the interface of the kitchen works as expected with the rest of the rooms in the house? Is the house built according to the what specification was looking? So all those things that you design, you're gonna execute that to make sure those execution criteria are met, right? So this is the testing arm. And because of its shape, it's known as a V model. Questions?
What's that mean, UAT?
User acceptance testing. We'll talk about all those different types of testing here probably later in the day today. Okay. It's important for you to understand this two structures because that's how it's going to be taught. Specifically, even in an interview or even as you build out the strategy for testing and quality assurance given system, you need to know how you're going to break it down at what level you can break it down. So now that you talked about the strategy and the life cycle, let's look into it. What do you need to build it at the analysis time in order to validate that, hey, I can test the system? Okay. So think from a project manager's point of view, right? Or a customer's point of view, who is like it's paying it to build the system, right? Going back to the house analogy, right? You give it, here are all my requirements. Then what is the first question you ask to build it? How much it's going to cost, right? So builder has to go in and figure it out. Okay, in order to build a house, what I need, right? So he's going to say, hey, I needed this much amount of the work to develop the house or construct the house. But then I also need to specify this much amount of time to do all those regulatory compliance and all the inspections. Right? But I need to know what all inspection I'm going to do it so that I can plan for it and how long each one of it's going to take it. So that I can plan it into my schedule. Well, a lot of inspection has associated fees. Well, how much it's going to cost me, each of the fees, so that I can put together and say, it's okay, it's going to cost me this much to build or construct the house, and it's going to cost me this much to test and inspect and get it passed through the necessary regulations so that it is considered as a livable house. Same thing goes into the software system. When a customer says, hey, I want to build a system, right? You as a consulting firm or an IT arm within that company, it says, okay, you want to build this thing, it's going to take this much. In terms of time, it's going to take you this much in terms of dollar amount to build it. But how do they come up with the dollar amount, right? So for the developers, they will go and perform the test and say, if you want me to write this particular software, it's going to take this many developers, this many weeks to write. But they're going to turn it around to you as a quality assurance person and says, okay, here's the requirements, they're going to build it. What's going to take you to validate and prove that the system works as expected in the requirements? Right? So you have to come up with a test plan. You have to come up with how long it's going to take you. Right? What tools you needed in order to test that. And what will be the overall cost to do that? So the effort that you put in to build out that thing is called a test plan. Okay. So the purpose of that test plan is to create what all things you're going to test. What will be the scope? Who all is going to be involved? Do I need only one tester or do I need 10 testers? Do I need a tester with this just one skill or do I need a tester with a different skill? And we'll talk about different types of testing a little bit later. And then you can see it literally, why some of the testing will require a little bit different skills. Okay. How long it's going to take you to complete each of the tasks. Right? So what, how, and why is filled in each one of them. Right? Why do I want to do the test? Well, to make sure I can validate this. What I'm going to do it, well, I'm going to perform this all task. How are you going to perform the task? You have this 2 people going to go run this execution. Typically, this document or a plan is created by a person who is playing a lead role in the quality assurance team. Now, if it's a small company, right, in this, you're building a small system, there's only one quality assurance person, and that person is going to perform this task. If it's a big company or you're building a big system, you're going to have a team of quality assurance people who are going to tackle that system. So whoever is performing a lead role, or a lot of times who has prior experience to build out those kind of things, they're going to essentially write this test plan. And everybody else is going to provide an input so that that person can create a plan and then give it to the project manager. Now, what does it contain? Right. So it will contain the scope. Okay. Well, if you're going to test it, what are you going to test it? What is in the scope and what is not in the scope? For example, like you talked about the building an Amazon system. Right? You're going to have some functional requirements. You're going to have a whole bunch of non-functional requirements. So when you say it's, hey, I'm going to test this system. Well, what is your scope? Is your scope both functional testing and a non-functional testing? Right. Think about one of the non-functional testing is it's not only the functionality works, but does it respond within that specified time? Can I have 1,000 users logged in at the same time and still gives the same performance? Right. What is my scope? Am I going to do both, or am I going to just focus whether the system works as expected or not? The approach, well, how I'm going to test those things, how many people it's going to require, right, which is part of the resources. Well, what software tools or licenses I needed in order to do the testing. Because there's testing software that allows you to automate certain things. Well, am I going to use those automated software and automate certain things, or I'm going to do everything manually? Okay. Then it also talks about the schedule. Well, how long it's going to take me, right? Because we talked about, when you think about it, all of this requires you to do some work, right? Well, how long it's going to take you to validate the requirements and write acceptance criteria? How long it's going to take you to write each one of the detailed design step-by-step instructions? How many times you guess that you need to execute it? And how much time each one of the execution is going to take, right? So those things, it's going to be all part of the schedule. What all things I'm going to do it and how long it's going to take me, and in what order I'm going to do it. Then that's great. Then you have to go into detail in terms of what level of features I'm going to test it, what all things I need to test it, what task I'm going to do it, how I'm going to allocate the task. Okay. The more important thing is the risk required contingency plan. So whenever you're building certain things, if it doesn't go according to the plan, well, what are the factors that's going to make it not go according to the plan? So let's go back to the house building. So I'm building the house. Let's say it requires some concrete pouring, right? One of the risk factors is, hey, I don't control the weather. What if in the week that I'm planning to pour a concrete keeps raining? I can't go out and pour a concrete while it's raining. it's not gonna work, right? Because otherwise I have to redo the whole thing again and again. Well, if it rains for a whole week, I'm gonna miss that whole week in terms of schedule. What is my contingency plan? Because I said that, hey, I'll get the structure ready in 10 weeks. And if I already lose a week because of the rain, well, how am I gonna make it up the plan? Does it require me to, hey, I'm gonna go ahead and make it an 11-week now schedule instead of 10 weeks? But it's not as simple as just making 11-week schedule, right? Because what if that crew is planned to go somewhere else? Now everything cascades. But guess what? If I don't have them planned to go anywhere else, they're just sitting idle, but I'm still paying for them. Okay? So my cost goes up. How am I going to manage my cost? How am I going to manage my timing schedule? What is my strategies to do that? That's called contingency planning. In the software world, right? You said that, hey, I was going to get the software on such and such date so that I can start my testing. Well, they said, hey, we are not ready. We will take 2 more weeks. Now, what do? Do you delay the deployment time? Like it's for all of you heard about the Apple, right? They just announced an event. They had it like it's event last Tuesday and says, hey, we're going to announce it. Goes out to the whole thing, right? Firm's reputation, all the detail. What if your team, which is making that iPhone 13, comes back and says, it's not going to be ready for that show. I need 4 more weeks to do that. Right? The business group says, well, all the invitation has gone out. There's a PR and everything. All the providers, like it's AT&T, Verizon, and everybody, is expecting a shipment by this date. People are going to order it. So it's not unacceptable to go out in 4 weeks. What can you do? And they say, hey, what if we don't you delay this feature? So instead of like it's giving a Pro Max camera, it just says, hey, we'll just still give that, but we'll update the software later on to add additional features. Is that unacceptable? Right? That's a risk claim. Hey, I don't have to test that feature, so my testing time goes down. Right? So now I can accommodate hardware being delayed by 4 weeks to deal with that. Okay. Then question comes around what tools I'm going to use. Okay. There are like it's a whole bunch of tools, and we'll start using some of that. So it's a listing of it. And the reason why you need this tool is to make sure, do I have a license? Or do I have people who are trained in that tool who can use it? Because if I'm trying to use a tool that is not available, that is extra cost that somebody has to purchase for this project, if nobody's trained it, then I need to make sure I allocate a schedule or time for somebody to learn the tool before they can start using the tool. Deliverables. It also talks about, hey, what all things I'm going to deliver. So one of the things you're going to find is, say you start quality assurance activity very early in the life cycle. And if the project was going to go for 6 months, your project manager is going to say, okay, tell me how you're going to tell me that you're making progress on time. Right? What all things you're going to produce it along the time so that I know that you're progressing. Because in a big system, right, a lot of times you have a team of like 10 people who are defined as quality assurance people or software testing team. Well, 10 people working it for 6 months, significant amount of expense. Right? They're going to say, well, I want to make sure you guys are working and reaching to the target that you're looking for. So what are you going to produce? That becomes all of your deliverables. You could create a report which shows how much progress you're making it. Right? So for example, you're doing an acceptance criteria, you're doing a planning and design, or at some point you're going to start execution. Well, how much things I tested, how much is still left, how much thing I wrote it, how much is still be left, build them. all of those things, the progress reports becomes a deliverable. Then you successfully test it, test results becomes part of your deliverable. And then we'll talk about certain metrics. Those becomes all of your part of your deliverables. The next thing it's going to contain it is what procedure I'm going to use it. Is it manual? Is it automated? What I'm going to use it. Is there a specific template that I'm going to use it for every test, or everything is going to be different? What guidelines I'm going to use it? And more important thing, what are the documents I'm using it as a baseline? So think about it. You started with a certain sets of requirements document. As part of contingency planning, you have to change certain things into that document. Now, the estimate that you gave it originally was based on the original document. So if your scope changes, your estimate is going to change. Right? It's either going to go up or it's going to go down. So it's an important, when you say that, hey, I'm writing this test plan, it's important. Well, this test plan is written based on which document, based on which requirement document, based on which design document. And it also talks about the test scenarios. So think about scenarios as a situation. And then test cases as a particular path into that situation. So let's say I want to make sure that I reach to my class on time. That's a scenario. And the test cases is that, hey, someday I may walk to the classroom. Other days, I may just drive it to the classroom. Okay. Some days the roads are clear. The other days it's snowy, roads are slippery. So the scenario is, I want to go to the classroom. Test cases are the different ways you can go to the classroom. Or different things that you need to do it in order to consider that you're reaching class. Okay. The scenario, so it's think of it, the situation occurs in the software. In test cases, which path or what conditions you're testing it or writing it against it. Then the test script is nothing but a step-by-step instruction. Well, if it's raining, well, what I'm going to do? Well, I'm going to first go make sure I have either a raincoat or a poncho or an umbrella. Right? That's what kind of like it's all those scripts. Then it contains two different types of metrics. One is a product metric and one is process metric. So think of product metrics as if somebody gives you a software and you're testing it, okay, and you find that every 3 test cases you're running it, you're finding an error, or you are finding it 10% of the test cases that you're running it failing, right? That's an indication of product metrics, right? How many test cases you have for this product and what is the rate of its failing? That's more on. The second thing could be is a process metrics, right? How many test cases you're writing it, and then how much you're writing it in terms of per day, per week, those kind of things. Like how fast is your process metrics? Now we'll look into specific examples of product and process metrics as we go through. And we talked about the test cases earlier. Okay. So whenever you're writing or trying to do any testing, you need 3 pieces of data. The first thing you need it is what is the input? So let's go back to our simple example of calculator. Okay. If I'm writing a test case for 2 + 2, well, let's talk about it. What are my inputs? My inputs are numbers and an operation. It also talks about what are the conditions in which to calculate the system. Right? So am I adding 2 plus 2 on top of an existing sum that I'm already tallying it? Or is it starting from a 0? Well, based on that, my answer is going to be different, right? So what is the condition of system is going to be? So let's say if I'm trying to create a credit application. One scenario could be, hey, I'm trying to start from scratch. Other scenario is, hey, I already have a pending and you're trying to create a new one for the same thing. Is it a duplicate? Am I allowed to create a duplicate or should the system reject it? What is the scenario or condition for this particular test scenario? And then what is expected behavior? That means if I'm running it this input, and here is the state of the system, what should be the output that I should expect? Okay. So your test case should have all 3 pieces of information. Okay. Now, again, as we talked about earlier, a good test cases is the one that we should be give you the ability to find the actual error in the system. The last 2 isn't important. Whenever you run a test case, you need to make sure that it gives you an unambiguous result. So for example, if I'm running a test, which is trying to measure if I get the response within the 2-second time frame or not. You run the test and then you ask question, did the result came back within 2 seconds or not? And if you said, I don't know, it might have, it might not have. Is that going to be helpful to anybody? It won't, right? Because it gave you an ambiguous answer. Versus if you say, hey, yes, I ran it and it came under 2 seconds. Or in this particular scenario, it didn't come under 2 seconds. Right? As long as I give an unambiguous result that somebody can inspect it and says yes or no, then it's a good test case. The other characteristic that we need to do is it has to be repeatable and it has to be predictable. So if you're using calculator and if you run 2 plus 2 scenario 10 times, will you get exact same answer? Probably yes, right? Because given the same condition, given the same input, it should always produce the same output. If it doesn't, what do you think about that calculator? It's not working as expected, right? And it's an error-ness, you're not want to use it. But you want to make sure that every time you run the test case, the instruction that you gave somebody to run it, can they repeat it over and over again and get the same result? If yes, then your test case is repeatable. Can I take the same instruction and run over and over again? Yes. And is it predictive? It means every time I run it, should I expect the same result? Yes or no? And we will see it as we go writing the test cases, what you meant by repeatable. Then it talks about the test standards. Unfortunately, when you go into the software world, like the term most of the people use is computer science. When you touch the hardware, then there's use of a term called computer engineering. And the reason why they call it science is nothing but an hypothesis, an experiment. Right? Versus engineering, it's specific input, specific predictability and everything. So in the test scenario, in the test case, you cannot have standards in a science. Right? You just have hypotheses and theories. Same way in the software testing. Because of the vast variety of things that they end up doing, you can't have the standards. you can have a good practices that you use it. So for example, if I'm testing a software which is designed to send a rocket to the space, the standards and things that or practices that I will use to test that software, it's going to be different than the standards that I use it to test something which allows me to order a book online. Okay? It's two software, but both are software. Both have quality assurance associated with it. But the way you approach it and do it is going to be completely different. Because of that, you can't expect it that, hey, when I'm writing a software, then for every software that I write, there is a cookie cutter template and cookie cutter standards that I can go ahead and apply it and use it for testing. The way you test something which works in a data center is going to be different than something which is working on your laptop or on your phone, right? So because of that, what you do it is they're trying to define it as high level, what is known as a process aspect. Well, if you're trying to do a testing, well, what process you should follow? Right? What are the different techniques you can use it? Okay, and how do you document those processes for the test cases and results? So those kind of practices that what they provide. But they won't say, hey, you know what? If you're building an online system for retail, no matter what type of retail system you build it, here is sets of test case you just executed and you can validate it. Because everybody's going to be different. So what are you going to see in test plan? Then it's not the standards, but what processes I'm going to use it, what type of documentation I'm going to write it, and what are the test techniques I'm going to use it. And again, it's good so far. Okay. Another important thing that you write it in the test plan is what is the environment you're going to use it to test it. Okay. So what you're seeing here is 3 different high-level areas or groups which are commonly used in the software world for essentially building a software. Okay. On the right-hand side, you have your actual production environment, which all of your user uses it. So when you go to order something at Amazon, right, and you type in www.amazon.com and try to go through it, you're going to end up in this environment as a user person. This is where your live data is going to be. Okay. Then there are 2 lower environments or 2 sets of lower environments that people talk about. So if I'm a developer trying to build a new functionality for Amazon, right? I'm still in the middle of working, right? Things is still evolving. I'm not completely done with all the work that needs to be done. So I'm going to take you back to the V. Okay, I'm writing this code. Right? There was a whole bunch of things which is not working when I'm at this level, writing a code for this particular program specification. But I need somewhere to test that hey, whatever the small piece I wrote it for, before I assemble with the work from other developer to bring it together and work. Surely I can do that into the live environment where my customers are interacting, right? So I need some sort of environment where I can do it, that work myself. And by the way, I know that since I'm constantly writing this thing, things may not be working. So I'm constantly building it and tearing things apart. Maybe hourly, if not every other minute. Okay, so I need an environment which I'm free to bring it down, doesn't work, I need to scratch it up and rewrite it things, right? So if you think about it, right, the kids goes on the beach trying to build something, things doesn't work, they break it. They're trying to rebuild it, right? A lot of times we call things as a sandbox, right? Hey, I'm using sandbox to build things. Doesn't work, I'm going to destroy it and redo it. So the most lower environment or unstable environment is typically the developer environment. So your one extreme is where your customers are, it needs to be highly stable. It can't keep changing every other minute. Another extreme is where I'm a developer, I need to work constantly and change things constantly. It's great, but if you're a quality assurance person or tester, right, you need to have an access to the new features. But at the same time, you want that environment to somewhat stable, right? Think of this way, right? If I'm using a calculator and in the middle of my 2 + 2, somebody says, hey, I'm going to wipe off your calculator. I'm going to put you completely new algorithm, right? How effective I will be testing it? Probably not much, right? Because constantly things are changing, disturbing my work and testing. So I want some sort of stability. But I want the flexibility at the same time. If I identify something is not working, then I want them to be able to change it periodically so that I can continue to work on it. Right? So that's the LAN where all the test environments are. That's where the developer essentially performs some builds and give it out to you regular. And a quality assurance person takes that and tests it. Okay. So this environment is highly transient, highly changing. Every so often, maybe once every 24 hours. Like they said, here is the stable version. Now I know this thing is working. Can you go test this? Or if you're doing a big end-to-end testing, which requires days worth of testing, then they said, hey, you know, if you change the environment every day, that's not unacceptable. Let's change it at once a week. So you continue to do testing, identify the bugs. I'll give you, they keep fixing it. And once a week, they said, okay, here is a new software version, go ahead and use it. And it fixes this thing so you can test those things. Okay. So typically in a software world, the progression happens from left to right. Okay. Developers have their own environment known as either sandbox or development environment, which is somewhat, I would say, unstable from the functionality point of view because they're constantly changing and adding new things. And at some predetermined point, they give it that to the testers to test it. Now, depending on the type of work that the tester are doing, you may have one test environment or you may have multiple test environments. Okay. So if you're testing a big system, typically you want to have a dedicated teams to perform dedicated tasks. So if you go look into that view, right, there are 4 levels of things. So at each level, you may have a dedicated team. And they may want to like just say, hey, I want to have my own environment. I don't want anybody else testing it and changing the state of the system. Right? Because at the end of the day, it is the state in which the system is. So all your input and output is in the context of the state. So for example, if I'm creating a new dealer, right? Well, it depends whether I can successfully create that dealer or not, is in what is the state of the system. But while I'm creating it, somebody else is also creating it, then I can't guarantee that I'm going to get the next sequential number, right? It's a toss-up. Depending on who races fast and clicks that button, they're going to get that number. So I needed potentially sometimes different test environments. And depending on the type of work you do it, it might be known as a system test environment. It could be known as integration, or it could be end-to-end testing. Because remember, when you're building things, you may not be running everything in isolation. So a banking system, right, when it runs it, they have multiple systems that runs it and runs in a unit ship. Keeping to the example that we talked about, the Amazon, right? Think about it, there are multiple systems running. There is a product inventory system running. There is an ordering system running. There is a purchase system or payment system working. There is a shipment system, right? Each one be completely different system on its own. And whenever I try to introduce a new functionality, I need to make sure that it works from end to end, right? So the environment in which they test it is known as end-to-end because you have all those system provision, and then you drop the new version of a particular system that you're working in and make sure nothing breaks. Then we talked about ability to say, hey, 1,000 users are coming in or 1 million users are logging in at the same time. Is my performance is still going to be the same, right? So the way I'm going to test that, it's going to be a little bit different than the way I'm going to log in as a single user and test the functionality, right? So I may have a load and performance environment. And then I may have a dedicated environment where it says, hey, we as a quality assurance and IT team tested everything. Users go ahead and test it. This thing works according to you. So they may have their own environment called the UAT environment. Now, if I'm a small company, a startup company, I'm not going to have money and a budget to run all this in different environments. Right? So I can just say, hey, my system and integration test environments are the same one. Or I'm going to use the same environment to do all this 5 things, but I'm going to time slice. Right? So first 4 hours, it's going to be used for this. In the night, it's going to be used for this. Right? And while the users are available, they can use it for you. So you can have a multiple test environment to do different tasks, or you can have a one test environment and time slice to perform the different tasks. And then at some point, once you finish testing and everything is working as expected, then you will have what is known as the deployment or release. That's going to take that piece of software and update the production environment or operational environment with that capability. Okay. So from a left to right is the flow, which goes through software. Now, if I'm a tester, definitely I don't want to test anything in production. Specifically, if my operation that I'm trying to test is destructive. I'll give you an example, right? If you're building a 911 system, right? You don't want all the faults called to be tested in production and send it out to a whole bunch of people, right? Whether it's alert or send a fire truck at their home or send the police at their home, just because you're testing. It's a no-no, right? So certain things, because of your testing and altering the operational data, you don't want to do any testing in production anymore. Now, if I'm just reading certain things, right? If I'm just fetching it some information only, then that's my operation. A lot of times known as a non-destructive operation or non-destructive testing. Then it may be okay in certain conditions to do that. Right? But typically you should avoid this environment altogether as a test. On the other end, right, you want some stability. You don't want things to be constantly changing while you're testing. Right? And then development environment, things are constantly changing. So you don't want to conduct your test in the development environment. However, there may be scenarios where the developer say, hey, I just updated that. It's a small, quick fix, but it's going to take me overnight to deploy it into operational environment because I have to follow all these processes and need to get all this approval. But I don't want to hold up your testing. You can just point it to the dev environment where I fix this thing. Maybe okay for a time being, right? So there might be a scenario where occasionally you might be going into this environment or going to this environment to test certain things. But for most part, as a testing team, you should stick it to this sets of environment. You guys good? Understand the difference between those 3 environments?
Can you explain again the system? What's the difference between system test and end test is like from starting to end is all the blocks they're working, like, right?
So typically end-to-end environment testing covers not just only your system, but interacting systems all together into one place. Right? So for example, within the testing for an e-commerce system, right? Let's say, hey, I updated something into my shopping cart, but I want to test it from the point that somebody can search it, add into the shopping cart, can do a checkout, and then it can be shipped to that entire flow is known as end-to-end. So if I'm testing all of those scenarios, then that's good. Versus if I'm just testing it, does the shopping cart work? So if I add something into the shopping cart, does it shows that the cart is updated? Right? Versus integration is, hey, I'm trying to perform a checkout operation on shopping cart. And one of the requirement is I want to do it is make sure my customers know. So that means I'm going to force them to log in. Well, then I need to integrate that with the authentication system to make sure it's that, right? So that's an integration. So depending on the scope of things and what you're testing it, it's going to be different environments. So we'll talk about it and talk about all the different types of testing. Any other questions on the environment? All right. The next set of things that you need to plan for it is how are you going to get the data? So it's great you write all these test cases, but what data are you going to use? So you have to put together a strategy which says that this is how I'm going to get the test data. And depending on the role and the type of systems you're building with, they may say, hey, you know what? We'll copy the data from production and give you in the test environment, and then you can use that data. Or if you're using a healthcare system, right? Because of HIPAA constraint, you can't just take that data and give it to test environment, just go test it because there are people's information into it. That means you have to use some other mechanism, right? And the way you can do it is by generating some dummy data. Now, who generates the dummy data? Do you as a tester generate the dummy data? Or your end users are going to give you, here is all the data that you can use for this. So depending on that, that's a strategy that you need to put in. And then your test data should be such that it allows you both positive and negative test cases. That means it should allow you the normal flow, as well as it should allow you to test what we talked about, what happens if then else scenario, exception conditions. Right. So we talked about the division, right? What if you divide by 0? Well, that's an exception condition. You need to have the data that allows you to do those conditions. Then it talks about what kind of engine you can use it to execute those tests. Are you going to write all of the tests as manual tests and have some human run it? Or you're expecting it to write an automated test, and then you want to schedule it every so often to run? Because if you want an automated rate, that means you need a software, you need an additional tools to schedule it. Thing also talks about manual versus automated testing. So manual testing is a set of testing where you need some human intervention. In order to complete that, at some point or at all point, you will need a human intervention. So typically your user acceptance testing, like it's how the users will be using the system. When somebody is doing it, they are always going to be manual testing. Versus if you're trying to do an automated testing. So if it's a code driven or a interface driven, then it could be a automated testing. So for example, in the Amazon systems we talked about, I may be interacting with the financial payment system. So I'll give you credit card information. I'm going to run it against some systems. And then system is going to get me a response, whether this is a valid payment or not. Right? I can do two ways, right? I could have them an interface or page where they plug in that information. And then they actually send it and get the response. And I display that response on the screen. That's a manual way. Or I could just write an API because I know, hey, it's going against some other system. Right? I can give that, here is the input file, go run it against it, and then get the output, and then just capture the output in the system. And I can do that in a automated way against whole sets of data, send it to them and get a whole bunch of responses. Because I'm trying to see if the interface is working or not. All right. So that's an API-based testing. Right. And you can essentially convert that into automated way. You don't need anybody intervening for it. The other aspect is a code driven, which is typically done by a developer. Is that, hey, I'm going to parse that code. And then for this particular code, I'm going to create this system, this condition, and I'm going to run the test. So typically, if I'm trying to do some testing to do a non-functional scenario, right? So, for example, if I'm trying to test it, does the system performs with the same response time? If it's a one user or if it's 5,000 users. And if I'm trying to do that kind of testing, it's easy when it's a one user, right? If there is 5,000 users, I'm not going to have 5,000 computers and 5,000 people sitting behind it and trying to hit all of them synchronously, right? I have to build some sort of tools that will allow me to simulate that environment, and that testing is an automated testing. Okay. Then you talk about what's going to be the velocity. The velocity could be for different factors, right? It could be a design time velocity, which says that, hey, I'm able to write this many test cases a day or a week, right? Or it could be velocity, it could be at execution time, that, hey, I'm able to run this many test cases on a daily basis, right? So typically it's something that you're measuring it over a specific period of time is the velocity. And then in the case of this one, what are the different test artifacts that you're using it as a metric to do that? Now, one of the things we mentioned, right? If it's going to take us 6 months, you want to report your progress. That means you're going to generate some reports. And you can generate a whole bunch of reports, right? Things could be is if you have the execution time, you can generate the report around how good the testing is progressing. And it helps the project managers to understand it is, are we going to meet the deadline or not? So for example, right, let's say I have to run 500 tests in order to test a system. And I have 10 test days. And if I'm running a test velocity where it's only 10 tests a day, do you think I can meet in that timeline? Probably not. That means I need to worry about as a project manager, either to give you more time or give you more people so that I increase 10 tests a day to higher number, which is 50 tests a day, because that's where it's going to meet the timeline. The other thing is quality of the software being produced. I'm running 10 tests, but 7 of them are failing. 70% of tests are failing. Well, that tells me I have a lot more work left because somebody has to fix that code and I have to rerun that test to prove it's working or not. Okay. Again, both of that results into see if I'm going to deliver the software on time or not. And some of the reports that you can generate it is functional testing. Remember we said that our flow has 7 functions. And just says, hey, how many of the 7 functions are working as expected? Is it 1, 2, 3, right? And then you can draw a graph and get a timeline. You can do it also is how many tests defects are detected versus fixed. So you say, hey, on a daily basis, I'm identifying 5 new defects. And on an average, it's taking 7 days to fix a defect. Now you can get a projection and say, hey, am I going to meet the timeline? Because it's taking them more time to fix that than the more defects that I'm producing. Also, defect distribution. Hey, all the defects are concentrated into one particular functional module. Or is it distributed across all of them? Gives me an indication. Do I have a poor design on one functional module? Or the problem is across the system? Then there are things that you can talk about is, hey, how many test cases I'm done with testing? How many test cases are still open to be retested because of the defects associated? Versus how many I haven't even tested or started testing? Then the working timeline, right? If I have 10 functions, at what point which function has started working? And at what point it breaks? Things that you can talk about, we already mentioned about defect found versus defect fixed. Average age. So, hey, how long it's taking to fix this type of defect and how it is distributed. Another aspect that they talk about is the severity of the test defects. Okay, so when you are writing the test cases, you can say it's, hey, it is generating a defect. Well, what is the impact of this particular defect? Let's say if I'm testing it out, a credit application creation function for test. Okay. In the software, one of the defects is they don't accept a social security number at all. Well, now we know that, like, it's, hey, your lenders is most likely going to use your social security number to figure it out what is your credit history. So they can't do any of their work. You can say, hey, that's an important, because without social security number, they can't do anything with that. So even if your functionality is working, it will be useless unless you fix that defect, right? So they can categorize that, hey, this is a critical defect. Okay. Versus you say something, it's just a cosmetic. Hey, you know what, this box should be aligned across the label, but it's a little bit off. Is that much critical? You can potentially go into production even with that cosmetic error, right? It's great if you get time, fix it. If not, fix it into the next release type of thing. Right? The impact of that will be almost null or minimum. So depending on the impact level that the defect that you identify, it can be categorized into any one of those things. It's critical, high, medium, low, or that. And typically, most of your companies will have a definition associated with when to consider a certain defect as a critical versus high versus medium. If not, you at the project level, you may have to define those. Then the second aspect is the priority. So my defects are generated by test cases. I'm going to categorize into the severity level. But the importance of the test can be categorized into the priority. So we talked about the contingency planning. But hey, I may not have sufficient time to run all the tests. A lot of times they will ask us, okay, great that you can run all 500 tests. Well, which of the 500 tests that you think you have to run in order to validate the system? Okay. Let's categorize all of them as a high priority. But unless those pass, or unless those are executed, we are not going to release the system, no matter what. Versus something is a low. Hey, you know what? It's nice to have that, There is a probability you're gonna find an error, but it's not gonna be critical error. So those test cases, if I don't execute it on time, it's okay. Right? So as you write the test cases, you identify the priority also. Right? Most likely, all of your login type of credentials may be high priority. Is a user able to log into the system successfully or not? You might want to test that, right? Because you don't want anybody to just access any private or sensitive data about people's credit application. Then we talked about the process metrics and a product metrics generated in the test plan. So any metrics that you use to measure the effectiveness of the software or the system is product metrics. Anything that you use it to test the effectiveness of process is the tool. And those things are process metrics. So for example, if you say it's user participation, right? It says how much time user participated for UAT versus how much total time you use it to test it. Right? That could be a process metrics, right? Because it talks about the process. It's a user involvement in the process versus non-involvement. Versus if you're using it, it's total number of hacks to be tested in the system versus how many I tested. That's a product. Because that has nothing to do with the process. Because depending on the product, you may have different paths. The number of paths is going to be different. So this one is a product metrics. This one, acceptance criteria tested versus total number of acceptance criteria. That's going to be a product metrics. How much of testing I'm done with this particular product versus how much is still left. Versus if I just say, hey, what is the cost to locate the defect? So as a team, how much time you spend it in order to generate a defect? It could be a process metric. How long it takes. And then you talk about the various test tools. What all tools you're going to use it? Okay. Now, what I want to do is let's take a quick 5-minute break, and then we'll continue with the test plan itself. There are a couple of things I want you to be aware of it, and then walk you through those things. And so we'll do that, and then we will jump into the different types of testing. So it's 10:33. Let's take time to 10:40. Okay. So we'll start back at 10:40. Go ahead and turn on the light on the right side. Looking for something? That's for the online. Let's see it if you have any questions. Are you guys good so far? Do you understand what requires in the test plan documents? You guys back? Ophelia, or Bobby, or Liddy, are you guys back?
Yes, I'm back.
Any questions so far?
No, just trying to absorb everything, basically, all the information. Not so far, but if I do, I'll ask.
Okay. All right. So we talked about the different tasks that you perform. So what I want you to do at the next is you had an opportunity to read the requirements document and design document. Okay. And at this stage, and I understand you don't have experience or you don't have a proper way to identify a structured way to see how long it's going to take you to test it. But if I ask you to take a guess, okay, given the system that it's in front of you, which is our form, if I say it's okay, if you have to guess how long it will take it to test it, what would be your guess? People, you want to guess all the functionality. Let's say I give you all the functionality and says you need to test only functionality, not the non-functional aspect. How long do you think it will take it?
So it will be only the upper layer user interface layer that I'm supposed
All of the functional. Remember, like it's
Okay.
everything that is defined in section 2 of the document,
Mhm.
right? All those functionality. If I just tell you, just give me an estimate how long it's going to take you to test all of that functionality.
No idea. It's just random, I'll say number.
Just yes, sir. Your guesstimate based on your experience so far interacting with all the different systems in computer world. What would you say?
2 to 3 days.
2 to 3 days?
Yeah.
Okay. What about you? Jim?
Can you ask the question again? What was the question?
So if you have read the requirements document for our form, and at this point, if I tell you, based on your gut feeling, tell me how many days you will need it in order to test that system, what would be your answer? The Dimple said, based on her understanding of the system, it will take 2 to 3 days to test things. How about you?
The design document is a lot, so I would say probably a week.
A week. So you can just say it's a week. Are you saying 7 days or 5 days? Working days?
5 to 7.
5 to 7 days. Okay. Let's go to the range. Okay. How many days do you think it will take?
I would say about 2 days.
2 days. So we have 2 people. What about you, Shu?
3 to 4 days.
3 to 4 days. Okay. How about you?
And go to 3 to 4 days.
3 to 4 days. So we have 2 and that. How about you, Lena?
I need more time. I would think maybe 8 days.
8 days. Vidhi, how many days do you think you will need it?
I was actually guessing more of 4 to 5 days, but then in my head, I'm like, wouldn't it depend on the requirements?
So when you say requirements, all I'm asking as a tester, give me your best estimate of what do you think, how many days you will need to test the system.
4 to 5.
So I'll put you on the high end, on the 5. Okay. What about you, Ophelia?
I guess 7 to 10 days.
7 to 10 days. So, 7 to 10 days. Okay. What about you, Everly?
I would say 5 to 7 days.
And then for Wangi, how many days you think?
I would say 3 to 4 days.
3 to 4 days. So based on your gut feeling, like you guys said, it will take it anywhere between 2 days to 10 days. Okay. So when you are giving the guesstimate, okay, what process or what thoughts were going through your mind that made you think that it's 2 to 3 days? Do you think it was related to how big the number of requirements were? Or do you think that was a little bit factor, but not that much? What do you guys think?
No, it's not too much.
It's not too much? Okay. What about anybody else?
What is the question?
So when you came to certain days of estimate, right? What basis you used it to guesstimate that? Do you think the amount of the requirements influence that? Or no?
The answer is gonna be the amount of the requirement. The
Okay.
rules you need to follow.
Okay.
You said requirements and design, right?
Yeah, so essentially it's a design document is nothing but an extension of requirements, right? Just
Yeah.
goes into further detail.
I felt like it was a lot to go through.
Mhm. So that's why you said that 7 to 10
No,
days.
I said 8 days.
8 days. Okay, so I think this one, I can club this two together, right? It's roughly
Yeah.
week and a half or 2 weeks. So think of it, right? Anytime somebody asks you to guess it, right, your first reaction comes at, let me understand what all I'm supposed to do. Right? And when you do it, you essentially break it down into 2 factors. One is, hey, irrespective of how big the work is, this thing remains the same. Right? And then depending on how many widgets. So for example, I'll give you, going back to the house building example, right? Doesn't matter how many big the house is and everything, right? To draw an architecture around it, it's probably going to take the same amount of the days. Right? Whether it's a ranch home, it's a multi-story home, right? Or it's a 5-bedroom home or 10-bedroom home. Most likely, the architecture time is going to remain the same. But the actual amount of time to construct it, it's going to be dependent on whether it's a multi-story or it's going to be how many rooms and so on, right? So there is a constant factor that will remain the same irrespective of what type of houses you build. And then there'll be a variable factor, which is going to be dependent on that, right? So when you guys guess it, did you keep that thing in mind? What is going to be my constant versus what's going to be my variables? So typically when somebody gives you a task to say, tell me, which is you're going to end up as soon as you go into the workforce, right? Somebody is going to give you, here's the requirement document. Tell me how many days you will take it to test it. That's going to be one of the most common things that people are going to ask. Okay. So what if I say, okay, you will get paid based on the number of days. Right. So therefore, if I say to you, you say 2 to 3 days. So I'll say, great, I'll pay you for 3 days. And your responsibility to test it. Are you able to sign a contract for that?
So under 2 to 3 days, I assumed I have already like gone through the requirement document. Now I know what I'm supposed to do.
Okay, so let me do it the other way. what if I tell you, consider all the time you needed to do all the work, whether it's reading requirements, document testing or writing, then tell me how much estimate. It will change.
Yeah,
What would it change to?
that you asking how many days now?
Yeah, including reading requirement, how much time do you think it will be?
It's a week,
A week, right? So you will move it from here to here.
yes.
Because remember, if you're a politician, if you're a paid person, if you have to work on it, right? You just don't factor in, hey, the actual time, right? You also want to factor in the time you spend it to understand it, right? Because you want to get paid for that, because you did actually put the work on it, right? So now if I say, okay, Dimple, are you ready to sign a contract? That you will finish the work in 7 days. And if you don't finish in 7 days, there will be penalties, financial penalties. Will you be willing to sign the contract?
So,
Because you gave me the 7 days, right?
so if I want to have the work, I have to sign that contract, because I said it.
Not necessarily. If I say it's, okay, I will give you a choice. You pick how many days you want it. And then you sign a contract, but then I will hold you to that line. That you must finish that much work in that many days. What would be your estimate?
You mean you're going to increase the timeline? You want,
You are the one who is telling me how long it will take.
so like if, as you're saying, it doesn't matter how many days you're going to pay me the same amount. That's what
No,
you're
but
saying?
let's say if you're getting paid daily,
Okay.
right? And then you have a choice that, hey, in order to do your job properly, how many days it will take? But once you give that days or the timeline, I'm going to hold you accountable to that. How many days you think you will still be comfortable with 5 to 7 days?
Yes, because if I'm going to increase the days, maybe they are going to check with someone else in the market. So I have to be like,
Right.
along with the quality, I also have to be like, money,
Realistic.
from money point of view, I should be after my words.
So you're bringing a point, right? That's, you have to make sure that you don't give an outrageous estimate. Because then they said, hey, you know what? You have no idea what you're talking about. I would rather go with somebody else. Right? Or if you are a captive IT department, which by other means you are employed by the company itself, you're going to say, no, you're not going to get this. Here's what I will give you, and then deal with it. Right? So when you go into estimate, the most important thing is to come up the estimate that is more reasonable estimate. Okay. But then how do you come up with a reasonable estimate? So typically, what people do it is first figure it out. Hey, I'm going to have some set amount of tasks, just like architecture diagram, right? That we talk about building a house. And I'm going to have some variable. And that variable is going to be dependent on the number of requirements or number of test cases that I need to test it. Right? And I'm going to add those two. And then I'm going to give an estimate. Right? So they're going to give you essentially a fixed activity. So you mentioned reading the requirements document. That's a fixed activity, right? It may vary a little bit based on the size of the document, right? Because it will take you more time to read a 500 document versus 50-page document, right? But you will have a good idea that that's going to be fixed no matter how many test cases I write, right? And then there will be a variable activity. Okay. So the goal is to identify how many of each one of this are, and then come up with an estimate. Okay. So in testing world, the variable activity typically is, well, how many test cases I need to test it? Because one of the things, Dimple, you missed it probably when you gave your estimate is, remember all of those test cases, you should have a script. They need to be repeatable and they need to be predictable, right? So you can't just say, hey, I'm going to do testing it. You have to write step-by-step instructions. So writing in instructions, it's going to be closely correlated to how many test cases you need to write. Right? So the first thing you should always do it is when you get that requirements document, you just do what we call a lot of time is back of a paper napkin calculation. How many test cases I think I need to test, right? And one of the ways you can do it is by kind of like it's laying it out. Hey, how many scenarios I think I'm going to have it? How many number of users are going to have it? And what are the number of test cases I'm going to have it? What could be complexity? You just lay it down. And then you come up with it and says, hey, in order to do all those things, how many test cases am I going to have? Right? So for example, if something is a complex test case, then it's going to take definitely more time, right? So let me give you an example, right? If you're writing a test case to see if I can successfully log in into our phone system or not, that's going to be a relatively simple test case compared to the test case which says that create a credit application, right? Because credit application has a whole bunch of pieces of data that I need to write it, collect it, right? There's probably validation rules that I need to worry about it, more than one. Versus when I log in, all I have to worry about it is, hey, do I have the user ID and a password matching to what I have it in the system for them? Right? So one will be a simple test cases versus one will be a complex test case. The amount of time you will require to do a complex test case, it's probably going to be more than what you needed for the simple test cases. So you do initially this kind of analysis in order to test, well, how many different types of users, right? Here, I can just give an example of only site administrator, dealer, and lenders. Right? But you know, you have area managers, you have an R4 drive, right? You have some additional users. So you need to make sure you lay it out for each one of the users and you figure it out, hey, how many test cases I think I need to do. So for example, right, if I'm trying to do the search, right, and say, hey, you can do search on 5 different criteria, then I need to think about how many test cases I'm going to generate, right? Maybe I need to make sure, can I search by each criteria individually, right? So that is 5 test cases right there. Then can I do it through a combination of search criteria? If so, then that my number of test cases goes up, right? So as you read the requirements document, you just do a backup paper napkin calculations. Hey, it's a guesstimate at this point, but at least it's a more educated guesstimate rather than just taking a number from the air. Are you guys good with me so far? The first step is figure it out how many test cases you think you need to test. Then you look into a template. It says, hey, in order to do the testing, what all activity I need to do? As I mentioned, there will be some fixed activity and some will be variable activity. Well, what are the fixed activity? Well, reading a requirements document, right? I'm going to write a test plan, build a test strategy, right? That's a fixed activity I'm going to do only once. Then I need to set up the environment. Remember we talked about the data and environment? Well, I need to set it up with the environment. I need to write the test cases, right? Step-by-step instructions. So that one is going to be variable activity. So if I have 100 test cases and each one takes me 30 minutes to write it, I will need a 50 hours worth of work. Versus if we're 500 test cases, well, now I need 250 hours. So you plug in all those things, then you plug in how much time it will require you to actually run those test cases, right? So it's called an execution. And remember, you have to guesstimate also. It's not only every time, all the test cases that you run first time, it's not going to pass, right? Some is going to generate an error or bugs. So you need to rerun those things. Right? How many of them you're going to rerun? So you need to come up with an estimate based on sometimes past experience, sometimes the companies will have templates. You plug in based on those templates. Okay. Then, as a quality assurance person, you're going to help your user, right? You pass, you tested everything, but when the users are doing it, if they're running into the issue, you may be sitting with them, or you may be testing on their behalf. You need to allocate those times. Then we talked about the contingency factor, right? What if the code is so much buggy that you need to keep rerunning testing mode? Well, how much percentage you can keep it for that? You keep it all those different hours, and then you add all of them. Right? And then you come up with a specific number and say, okay, this is what my estimate of what's going to take. So this one, in order to do the testing for the airflow systems, our original estimate was that it will take about 67 man days to do the testing, which is about 9 weeks or a little bit more. Actually, when you take it, this is business days, right? So it's about 14 weeks of testing. Look at your estimates. Right? And again, there's nothing wrong with this. What I'm pointing it out is that as a tester, there's a lot more than just running the test. If you were thinking about all of this times, you were just thinking about running the test. You were not factoring in as, well, how long it's going to take me to write it, step-by-step instructions. How long it's going to take me to generate the data or come up with the data. You're not factoring in how many times I'm doing testing. You'll factor all of those things in order to come. Now, you can just say, hey, if somebody asks, how did you come up with this 2 days or 10 days, right? You can say, you know what? Here is my logic. And somebody says that, hey, you know what? You need to cut it down from 67 days to 15 days. Right? And you should be able to just, you know what? It doesn't make sense. I don't think I can do it. If you find somebody else to do it, go ahead and do it. Because at that point, you know that you're going to be put in a situation that you can't do your job right. So use this kind of tools and methods to come up with an estimate when you go through. Okay. So one of the things I want to do is, yes, this is 67, but I want you to start thinking about how much time you will take it to write a one test. Okay. If you want, you can just jot it down, these numbers, on a piece of paper right there. And then I want you to rethink it when we're done with the course on the last day. I want to reflect it and say, hey, this is something that you came up and estimate without knowing everything that you need to do. Once we do all the course, then go back and do you compare the same days? Or do you think it will be different? Okay. Good.
If you give affection that 67 days, and then when you starting that little bit issues, you need to fix it. It's not gonna affect the
Well,
period
remember,
of,
because I put 25% contingency factor. Right? I said that, hey, you know what? If everything goes perfect, it'll take me this much time. But I know that nothing goes perfect. There will be some hiccups. Well, how much time I'm allocating for the managing the hiccups? I'm doing 25%. Because critical is, I need to come up with an estimate that I feel comfortable that I can deliver it against it. And I have some logic rather than just, hey, I picked up that number from the air. Right? Which I know for a fact that I ask all of you to do that, pick up the number from the air. Right? But I want to make sure, do you guys put some logic behind it or not? And the more of the experience you will have it in the testing world, the easier it will get for you. Oh, you know what, I have managed this kind of systems before, and here is what my experiences are around it. So let me put that much level of contingency.
So do they keep the margin like this 25% factor? It may be 40% or it may be like 20% or 15%. So do they keep the margin for this one?
Yeah, so essentially you learn it, right? The first one, you put it 25%. Well, then you learn the factors, right? Well, it was 25%, or it did came 50%. So we lost on it, but what contributed that 50%? So the next time you sit down, you put a much more higher condition and say, hey, you know what? I'm gonna put this one, assuming that developer will deliver on this time, it will be at least this level of quality. If it is not, then we need to relocate it, the estimate, or estimate will go higher, and it could go up to this much. Right, so you give the range at that point instead of giving a fixed number. Right, and then as the software starts coming in, you refine the range. And that's how we do it, estimation in the agile world. Is initially we kind of, based on experience, we lay it out and say, hey, it's going to take us this many sprints. But as you start coming closer and closer and more number of sprints, you're refining your window of uncertainty starts going down. So you can narrow it down much more easily. Okay. Any question on the process of how you should go think about estimate?
So in case like someone is asking for the estimate time, all of this, you can't give a number without going through a plan and jotting it down.
Yeah, so this is part of the plan number, right? So it's, you're giving it in that. So if somebody just goes and like drops a file on your desk and says, here's a system requirement, tell me how much it is, right? Your first reaction is, okay, let me read through it and I'll tell you how long it's going to take. Right? Because without knowing what you're getting into it, you can't estimate what it's going to be.
So that document is gonna say how many users.
Well, that document is not going to say, that document is going to list out requirements. You have to come up with an estimate of how many test cases you need to do. Right? And then you need to come up with the fact that, hey, I need to run this many test cases for testing this functionality as this user. For this functionality, I need this much. Because you will be reading requirements, right? And at that point, it says, hey, I need to test this, I need to test this, I need to test this. Right? And the more you have experience, the more easier it gets it for you to say, hey, I'm going to scan the requirements document quickly and then give you an estimate. So a lot of times you may need 2 or 3 passes through the requirements document to fully understand the impact and then come with an estimate. Or depending on if you already have an experience in that, you may just quickly scan it and give you a rough estimate and then take a time to give the detailed estimate. Okay. All right. So now let's talk into the work that you need to do it today at home. Okay. So remember I said there is a third document after reading the requirements document and specification of, there is a test plan document. I would recommend just read it. Most likely, depending on the teams that you end up, if it's a big team, you are not writing it, that document, somebody else is writing it, but it will give you an idea how a requirements test plan document is written. So in the case that if you end up writing it, you know what to look for. Now, given that most of the companies will have templates. Okay. And from a project to project, typically only like 15 to 20% of information changes. Specifically, as I talked about, the fixed activity is going to remain more or less same. It's the variable activities that you need to think about while writing it and coming with calculation. So it's not something that you should start worrying, hey, I don't know, I don't have experience, I need to do all this. Think about it as a template, it's more informational. Here are the type of things it gets into. Okay. Okay. Now, let's talk about different types of testing. So when I walked you through the week, like we talked about different things. And then when you do a review and design, there are a whole bunch of terms that you're gonna hear it when you get into industry. That, hey, I need to do this type of testing versus this type of testing. So let's look at it, all the different types of testing. Now, this is not a comprehensive list, but this is most commonly used type of testing. Okay, let's talk about who does it, when they do it, right? And what's the purpose for each one of them. So let's start with the static testing. Okay. So one type of terms you will hear it is static testing. Static testing is typically type of testing that you do it without running or executing anything. Okay. So typically when you review the documents and provide a feedback, you're doing some sort of testing. I ask all of you to read the requirements document and do 3C and a T validation. That's type of static testing. So, hey, can I test this requirement? Yes or no? Right? I'm just doing that validation. So typically when you do reviews or inspections, hey, is my code working as it should be? So you review the code and you said, yeah, this should work, or no, this might create a problem. Think about one more example, right? To give you a correlation. If you're cooking something and you're reading a recipe, just by looking at recipe, right? You can say, is it missing something or not? Or will it probably work or not? Right? You can say that. You don't have to actually cook that recipe in order to make a decision whether, hey, whether that's going to be an interesting recipe or not. Same thing in a software, but just looking at the requirements, you look at it, is it probably going to work, or do I know what details? Now, another type of static testing you're going to encounter, which typically most of the developers do it, you don't do it. Right? When we as a developer write the software, write the code, it's written in specific language. You will hear words like Java language or C# or C++ language. Those are typically higher level language. They're known as third generation or fourth generation languages. System actually takes that, the compilers take that high level instructions and then convert them into the system level language. A lot of times they're known as assembly language. Okay. So if you recall it, we did the 3 layers of a computer architecture, right? Application code, system code, and at the bottom, there was a hardware, right? So the system level of executions, right? The instruction that you need to do it. You're never going to write directly into the system level of program. You always write into third generation or fourth generation language. And then that converts into the system code. Now, the other key difference is each language, the third generation or fourth generation language, have rules that the language has to follow. Just like if you're writing a sentence in English, right? There are grammatical rules that you have to follow. Same way in the fourth generation and third generation language, have to follow a rule. When you run something through a compiler, it's a tool which validates that did you write it according to those rules or not, right? And can I convert this into the system assembly code language or not? You're not running an actual piece of software. You're just running that thing and converting it or translating it and says, yes, it worked. That's a static. At that point, you're still not running the software, but you're just converting it from one language to another language to make sure it follows all the rules. That's a compiler. Okay. Typically, you're going to see a static things happening throughout the life cycle, but more predominantly, it's going to happen in the requirement space and the coding phase. So implementation phase and a requirement phase where they're going to lean heavily into it. And the purpose of that is to verify. Will it work or not? Versus if I'm doing a dynamic testing, I'm running actual piece of software. Okay. And then I'm at that point, I'm validating it. I'm making sure does the system do it or not. The task is already done. All I'm doing is validating was it done properly or not. That's a dynamic because I have to actually execute a task to validate that, hey, did it done properly or not. So you're going to see this dynamic testing throughout, predominantly after the implementation phase. You're going to see all of them as a dynamic testing because I have to run a piece of software to do that. Okay, and typical examples for functional and non-functional testing. Another viewpoint you can put into it is something known as a black box testing versus white box testing. So black box testing is, hey, I don't know how it is implemented. And I don't care how it is implemented. All I care is, given this input, does it produce this output? That's the key for a black box. And the reason why it's called a black box is from your point of view, the entire implementation is not visible. You don't know. Right? So think of that as a black box testing. Okay. It tries to address what is the functionality of the system. Okay. Because I don't know how it is implemented. If I get into how, then it's known as a white box testing. If I know how the system is implemented, if I know what the architecture is used, and then I'm writing the test cases, I'm writing it with the knowledge of the behavior of the system, then it's known as a white box testing. A lot of times what we as a developer do is typically a white box testing because I know what the code is and I write the test case to make sure I cover every path and it works on every path. That's done with the knowledge of how. Good so far with those two views? Static versus dynamic, black box versus white box testing.
So in static testing, it says like code review. So like, so does it include like writing code as well? Like
So typically, all the developers do it is when they write the piece of code, they always sit down with the peer. It's as a good practice, they should always sit down with the peer and say, hey, I've written this code. Can you review it and make sure it does what it's supposed to do? Okay. Lot of times now the industry's moved to something known as a pair program. So when you write a code, you don't write it alone. You sit down with your peer and then you just like it's right over part of the segment, they look at it and say, yeah, let me pick it up. They write another part of the segment. So you're constantly reviewing it as you're writing it. And if there are a problem, you're spotting right there and say, hey, you know what? No. You're doing this for loop, it's going to go outside the bounds. Don't do that. Change it to this. That's a code review, right? You're not actually executing anything. And you're just writing it in and then you're looking into it. That's a static code review. Any other questions? All right. So now let's think about the V that we talked about, right? At the most lowest level of that V was the code, right? And once you write the code, the most closest test you can do with that is a unit test. You have a small piece of code written, making sure that works or not, that's known as unit testing. And typically this testing looks on a small segment of code and then make sure every path is tested. And typically, it's done by a developer because they are the closest to the code. They are the writing, right? You as a quality assurance person, it's not going to get involved in, hey, you wrote 500 lines of code, let me just review each line of code and make sure it works. That's their job, to make sure it is working as expected. And this typically happens early in the development stage. So as they're writing the code, they perform the unit testing.
So unit testing, does it include both static and dynamic? So do,
It could be,
okay.
right? Typically it is dynamic. But depending on how I've done it, right? If I'm doing a pair program, I'll write the code and ask somebody to look at it. It could be static too. Again, think about the different dimensions, right? Static and dynamic is the behavioral. Hey, what factor I need to, am I verifying or I'm validating? That's one view. Unit testing is what is the smallest level of code or smallest level of functionality I can test it? And who is responsible to test it? Those are two different viewpoints. The next level, if you go about it, you talked about the link testing, if you recall it. Right? So in this scenario, I'm writing a whole bunch of small pieces of code and I'm bringing it together. So if I wrote one module and you wrote another module, we're bringing it together and make sure they interact with each other as expected. It's not the whole system, but it's a small subsection. Can I do a checkout? I'm not doing the whole process. I'm just talking about only checkout process. Does it work as expected? This is also typically done by the developer because they are bringing the small segments of codes together to do the testing. And it's done typically a little bit later in the development. So you do the unit test first, and once that piece of code is working, then you try to merge with the other piece of codes which are working, and then do an integration test. Hang on to that. I'm going to come back to those sanity and smoke testing a little bit. The next level of testing is a system testing. Okay. So I move up on the stack. I have each of the functional module working as expected. Now I'm bringing them together to build whole system. So when I bring them, now it's working as a functionality, working that as the whole system. So this is the point where you as a quality assurance person starts taking over the testing functionality. Okay. So this is typically done not in the development phase, it's done in the testing phase. So you're moving the code. If you remember like 3 environment diagrams, right? The left was the development. You're moving now the code into the middle segment, which is the testing. And you're performing tests at that time. Okay. So typically it's done during the testing phase. And the purpose of that is to test the functionality of the system. Does all the requirements of the systems are fulfilled? Another type of testing is the regression testing. So let's say you found a bug. You were running the test. First 5 tests ran successfully. There was no issues. You didn't find any bug. The 6th test was successful and found a bug. Right? So now I tell development team that, hey, you need to fix this particular scenario. They go back, give the code, they fix the code, and they give it to you. When they give you the next version of code or next build, you need to make sure that while fixing that particular thing, they didn't break anything else which was working or not. What that means is you have to rerun those 5 things that worked successfully before and make sure they didn't break that 5 thing and they actually fix the 6th thing. That means now you have to retest the things that was working fine before. When you do that kind of testing, it's called a regression testing. Okay, I'm regressing it to what was working and making sure it's still working. And it's typically done by the test team. And you do that in the test environment or in the testing. Because that's when the developer keeps giving you new code. And then you're validating that against the baseline that was working. Okay. Good so far? All right. So let's go back to the two that I skipped. Okay. So sanity testing. So we talked about, hey, I was doing a system test, I find a bug, and I give a developer, hey, here are the issues. They looked at it and says, yeah, it's a bug. Let me work on fixing it. They fixed it and they gave you new code. Okay. When they give you new code, the first thing you should do it is determine, is it good for me to begin testing? So whenever somebody gives you, here's the new version, or here's the version of the code that you need to test it, the first thing you do it is it good for me to start the testing? Because what if they don't give me all the components? They give it, here's the two pieces, and you miss the third piece. How often do you encounter that scenario? Somebody tells you instructions, says, do this, this, this. You said, hey, it doesn't work. They give you additional instructions, but then you still can't do it, right? That means it's still not ready to test it. So when you do that kind of testing, to say, is it good for me to get started? That's called sanity testing. The perfect example is if you're building a web application and they give you, here is the new version of code, and it's deployed and it started. You try to go to that URL, which was used for testing, then you get 404 error. Right? So if you can't bring up a home page, can you continue with testing? You can, right? So if you go to www.amazon.com and nothing shows up, only blank page shows up, can you do any testing? You can't, right? So initially, the thing that you just put a URL and says, does it even come up? That's called a sanity testing. So whenever the developer gives you a new piece of code, the test that you do it to minimally figure it out, can I proceed with the testing or not, is known as sanity testing.
So is this testing done before the regression testing?
Yeah, anytime anybody gives you a new piece of code, you need to first make sure, is it good for me to test it? Right? Did they give every parts and pieces or not? Okay. That's a sanity testing. Then there is a smoke testing. This is also minimal testing. Right? So let's say my system has made up of 5 different components for 5 pieces. I need to make sure each piece is working as expected. So not only I can just bring up a home page, but I can log in successfully. That means my business layer and my database is working too. If I do that kind of testing, which is sanity plus certain things to make sure everything is working as expected to begin testing, is known as a smoke testing. A lot of times, if you are done into production environment, now this is in the olden days, and it's still true for some huge system that's supposed to work only 12 by 8 or 12 by 5 type of time. Okay. So anything which is cloud-based are typically 24 by 7 applications. But when you go look into certain old systems, which is still prevalent in many corporations, they're designed to run from 6 in the morning to probably 10 in the night. And then they go into the maintenance work, right? So they bring its system down, they do the data backup and all 9 yards. And the next morning at 6 o'clock, to bring the system up. When they bring the system up, they need to make sure it's going to work as expected before customer starts using it. Right? So they will do something similar to smoke testing, but that is the term that they use there is a sunrise testing, because they do it every day before the start of the workday. But that's done in production. Versus this scenario is in the test environment. Whenever I get a new piece of code, I'm making sure all the parts and pieces are working. And typically testing does that. And it's done in test environment. Good so far?
I'm not clear, like, what's, like, I don't think so there is too much difference between sanity and smoke. Like, they are very similar.
They're similar, but one is more extensive than the other one. Sanity testing, think of it, if I just go type the URL and see, can I have the homepage come up or not? That's sanity. I'm good to get started. Smoke testing is, I'm making sure all the components are working. That means database is working, the business wire logic is working, and the presentation, which is my homepage. All three pieces are working, then it's a smoke testing. They both are done whenever somebody gives you a new build. But one is it sufficient for me to get started? Is it sufficient for me to test everything that they're providing me in terms of functionality?
So after a new release, like whenever there is a bug, so they're going to open a flag and there will be new release for that. So basically in sanity and smoke, it doesn't matter that bug has been removed. They're just going to find
Can I start testing it again? With
as it was
the,
working before,
no,
before
with the new piece of code.
Okay.
Can I start testing or not? That's it. It's not even considering whether is it working as it before.
Mhm.
All it says that, can I start testing? Right? So that's sanity testing. Can I start testing all the components? That's a smoke testing. Okay. So for example, right? If you're going to a building, can I enter into the building? Right? That's a sanity testing. So smoke testing is, can I get into all the places in the building that I need to access to it? Right? Like a classroom, conference room, all of those things. Okay, so that's called a smoke testing. So then let's go to the next thing. Now it's a functional testing. So put another lens. We had a functional requirement and a non-functional requirement. If I'm testing the functional requirements, that's a functional testing. And typically it's done by the testing team in the system testing environment. Is this system working as expected or not? So try to, it's the same thing as the first one. Right? When you try to answer, does this particular feature work or not? That's a functional testing. Then there is a load and performance testing. Okay. If you're trying to do the testing, then make sure, does the system work under a load condition? That means if 1,000 users are logged in, is system able to still function the same way? How many times you've tried it something on the Black Friday, trying to order something, or you go to your stores where you want to order it, their website. Just takes forever to respond, right? Part of the problem is system is not performing under the load because there are way more users than what it was designed for, right? So as a testing, right? If the non-functional testing is in the scope, then you may end up doing it load and performance testing. The goal for this one is, does the system work under the expected load? So if you look into the requirements document, right, it specifies how many users going to log in at the same time and how many transactions could happen concurrently. And can you handle that many traffic at the same time? Do testing to validate that is a load and performance testing. Typically, this thing is done after you're done with all the functional testing. Because think about this thing, right? If the system is not working for one user, does it matter whether it works for 500 users or not? It's not working for each individual user anyway. So typically you do all the functional testing. Once all of them passes, then you begin the load and performance testing. Okay. Typically it is performed by test team, but it requires a little bit additional skills because this is where you start going from a manual to automated testing. This is where you get it from one transaction at a time to actual tools that is going to allow you to simulate. Okay, good so far? Then there is something called as a stress testing. Okay. To put this into context, let me ask a question. Have you guys seen a movie called Apollo 13? I'm like it's kind of also somewhat space buff. Right? So back in 17, right, like 69, US put the first man on the moon, right? And then they continue with a few more Apollo missions. And one of the mission was tagged Apollo 13 mission. And the whole purpose of that was to just go to the moon, have 3 more astronauts walk on the moon, collect the samples and come back. So the whole system was designed, right? Because when you send a human into deep space, so that means anything outside low Earth orbit, you need to worry about the oxygen system, you need to worry about the hydration systems, you need to worry about navigation systems and whole 9 yards. Right? So you design everything according to specification, make sure that it can handle all of those stressful conditions. So same thing was Apollo program, the Apollo 13 was designed and was launched on the halfway to the moon. There was an explosion with the oxygen tank, right? Because you had to carry an oxygen, and oxygen is one of the most flammable compound that you can think about it. So halfway to the moon, while performing one of the routine tasks, one of the oxygen tank blew up, damaged the whole craft. Right. So the goal at that point, the guy who was managing the whole mission, he said, so look, I need to bring those 3 guys alive back to the Earth. Right? So it's not something like, hey, there's a fire in the train, you stop it, open the window and walk out. You are halfway to the moon. You don't know at this point now how much fuel left, because oxygen is also used as fuel along with it. You don't know what is the condition, what equipments are working and what are not working, but you still need to bring those 3 guys back alive. And they are a day and a half away in the space. So if you get a time, I would recommend you to watch the movie. They actually decided after reviewing things that, hey, the fastest path for the astronaut to be back home alive is not to turn around and come, but actually to continue to go all the way to the moon and take a moon's gravity slingshot to come back to it. Okay. So, but in order to do that, right, they had to shut down a whole bunch of systems because they need to make sure they survive for now another 4 days instead of just a day and a half, because they have to go to the moon and then come back. So the reason I brought it up is in the context of stress testing. They had to take everything that was designed for and throw it out of the window. And they have to tell us at what point things is going to break. So it's not about what you designed for it, but at what point my system is going to break it. When you do that kind of testing, it's known as a stress testing. It's a destructive testing because you're making the system fail at that time. You're putting enough load to say it's, hey, system is no longer just not responding, but it's just crashed. So that's a little bit different than your load and performance testing, because load and performance testing is, hey, I know the system is designed for this much load. Can it handle that load or not? It's good, good. Stress testing is, I know system is designed for certain load, but at what point it breaks it. So I'm going to continuously add things till it breaks. Because it gives me a good idea as to what are my breakage points is. Specifically, there are certain things which is a life critical systems. That's what they use it. Like for example, 911 systems. So we just went through the unfortunate 9/11 anniversary, right? So when you look at it, that day, I don't know if you anyone had, I had a few friends in New York and I was trying to frantically reach them. You couldn't because 911 system was overwhelmed. It crashed. Same thing when Hurricane Katrina happened down in New Orleans. 911 systems crash. People cannot get through it when they dial 911. So while those instances are far and few, but the impact of that is significant. So people, when they build the system, they also run it, the stress testing, and identify at what point things is going to fail. Same thing with the hospital systems, right? When they're putting it, the cardiologists, right? Whether they're putting somebody on the ventilators, or they try to do it at what point the system is going to fail and impact it. So they do all those stress pointing and make sure system never reaches that point. Or if you know that it's going to reach to that point, you start looking at the alternate contingency to handle it because system is going to fail. Okay. So this one is trying to figure it out under what load the system is going to fail at. So a lot of big e-commerce companies like Google, Facebook, Microsoft, or Amazon, they do this kind of testing too. Make sure, since the user base is millions or billions of users, they need to know at what point it's going to fail, because that's going to impact. So I don't know if you notice it or not. Nowadays, if any one of those major social media platforms is down, it comes in the news. It failed, right? So it's a revenue impact, but it's also a PR impact for that. And this type of testing is done later phase of system. Not only your functional testing needs to work, but to some extent, you need to have a good understanding of whether the load and performance is working or not, at what point it's working. And it's typically done by testing. However, there are very few systems which will do that. So if you're building just normal e-commerce systems or Barnes and Noble and that, typically they're not going to go through these things. Because A, it's an expensive type of test. Two, it requires a specialized skill to slowly ramp up the load and figure out what point things fail. Okay. Then you said, hey, my now system is working as expected. It works under the load that it's expected. And I know at what point it's going to fail it. Now they say it's okay, now it's ready to go into the user's hand to do some final testing. Just like when you build a house, right? You don't get engaged till all of the testing is done by the builder, by the county, and they certified everything. And then they said, okay, now it's ready for you to come in, test it, and move. But that testing is known as user testing. Same thing with the system. You are getting all the way to the end, you're ready to deploy into operational environment. And before that, you're performing some final checks with the end user. So end user is coming in, and I'm trying to answer a question. Is the system usable by me? Does it allow me to do all the functions and the features and the tasks that I'm expecting it to do? When you do that, that's a user acceptance testing. That's the one of the last things. Look into the V diagram, it's at the top. Okay. This thing is typically done by the business users, or a lot of times it's also done by the quality assurance people or test teams. But it's done on behalf of business users. So they sit down with the business user and says, let's work it out what all you want to test it or see to pass it before we can deploy this into production. So when they do that, that's a user acceptance testing. Now, contrary to all the load and performance testing, this thing is going to be all manual testing, because this is how the user will log into the system and use it. Then there is something also known as a backend testing. So when you build systems, certain part of systems may not have a user interface. That means you have to go into the various backend part of the systems and then actually access it. Okay, so think of an example, right? When you're doing a non-functional requirement review in the R flow, the first one in a non-functional area was auditable, right? So every transaction, no matter who does it, needs to be captured in the context of credit application and logged into the system. Typically, you're not going to see any interface that says, hey, I put everything into the systems, here's all the records in that. Right? A lot of times you need to validate, you need to log into the database and run some sort of SQL query to make sure did it just posted the transaction that it did it. When you as a test team perform that kind of testing, that's known as a backend testing. It's either testing directly into the database or testing something that for which you don't have a user interface. One of the examples that we talked about is validating automated way the payment gateway is working or not. Right? That you can do it a backend testing. You can just write a script that just make a transaction to that. You don't need an interface, but you're testing all the systems and the backend interfaces. Then that is known as a backend testing.
So is it a kind of white box testing?
No, it's typically always a, from the systems point of view, it's a black box testing because I know what is going to be written in the backend. Like white box, black box testing is when I don't know anything about it. In this case, I need to know how the backend database is located so I can make a query and pull the data and see if it makes sense. Okay. Then there are templates, or think about the website. So about, I would say it's a good bit of 90+% of the new development that is currently happening happens in the web. Right? So you will have either mobile application or a website or something like that. So that type of software development is known as a web application development. So when you're doing it, a web application testing, in addition to the terms that we talked about, right, whether it's a unit test, system test, regression test, there are other aspects that you need to think about. So one of the first things that you're going to do is usability testing. I mentioned earlier that there's a whole new branch coming up in the software development called user experience. Okay. So I'm going to do a usability testing. The way typically people do it is trying to see how easily you can accomplish a certain task that the user is going to perform in the system. Is it friendly or not? Is it easier and intuitive to find the things that I'm looking for there or not? So that's known as a usability testing. It's more around the behavior of the system. Yeah, functional testing we've already talked about, right? It's a function. Does it system does from a functional point of view what it's supposed to do? Then another aspect you're going to run into compatibility testing. So in the case of web world, you don't know what kind of browsers or devices your end user will be using, right? Somebody could be using an Apple device, or somebody else could be using Android device. Somebody else might be using completely different Windows device or another type of custom device. So you do not have the control of what they will be using. They might be using different browsers, right? So if you look into it, Microsoft Edge just released a new version of the browser. Chrome constantly releases new version, and so does Safari, which is Apple's predominant. So you get a whole bunch of browsers. Well, when you deploy a web application, right, you need to make sure that your application works on multiple browsers and not just on one specific browser that you tested with it. Right? So when you do the testing to make sure your application works across multiple different devices and different versions of a client software, that's known as compatibility testing. Right? So when you're testing it, right, you can't test against each and every browser in the world which is out there against all the versions, right? That's too much in exhaustive testing. So typically your requirements will just say, hey, what is typical operating environment? They say, hey, my user is going to use either the Chrome, Safari, or this browser. Right? And then they said, okay, they will potentially using this version. So you look into it and testing it, making sure does the software works against those things. Okay. Now, one of the key things that has been evolving it lately in the last 3 or 4 years is all those browsers, as they are built using just 2 or 3 different types of engine. So when some company comes up and says, hey, we build a new browser, they don't build everything from scratch. They take what is known as the core engine for the browser from one of the 3 common engines and then build things on top of it. So a lot of applications now shifting it, instead of testing only in the browser, they're testing with the underlying code engine and making sure because if it works with those engine, as the people comes in and as long as the browser is kind of inheriting those engines, it'll still work on them. Okay. So that's known as compatibility testing. You may have to log in into 3 different browsers and test it and make sure the system works as expected. One of the typical example that where most of the application fails at is a lot of web applications enables a right-click feature. Works great if I'm working in computer. But if I'm working on an iPad or tablet or phone, I don't have a mouse that I can right-click. And it fails. Right? So that user can access half of the feature because they are driven by the right click of the mouse. So that's kind of testing is compatibility testing. Obviously, we talked about the database testing. Right? The backend testing, similar. It's the same thing as the database testing. Making sure whatever the data you updated goes into the database as expected. Another aspect is the security testing. Because specifically, I'm making sure validating the identity of people who say who they are, it's a critical, specifically into the banking applications or financial transaction related applications. Whether it's if somebody is placing order on Amazon by pretending who you are, you want the Amazon system to catch it. Hey, it's not me, somebody else trying to it's hack into it. Okay. Same thing with that. So traditionally, people looked at, hey, simple, I have to worry only about the login. But now I have to worry not only just login, but also encrypting the data because it's going over the public network. Right? It's going over the internet. It's no longer on dedicated networks. So in a web application world, you need to worry about security and making sure the data is secure and the access is secure both. And another important aspect is, as you looked into Airflow, right? Depending on who I logged in as, I can access different functionality. Not everything is accessible to everybody. Right? That's a part of the security testing, right? So people talk about that as authorization testing. So authentication is proving who I am or identifying the user. Authorization is, can I access what privileges I have? We talked about the performance, right? System needs to respond within certain time frame. Specifically, it's important when you do the financial transactions. If you're doing anything like stock trading or getting into the investment or your retirement plan, you need to make sure that the performance testing is done accordingly. Okay. Another angle that you need to think about it is if the application is run on mobile devices also. Remember the mobile architecture we talked about is ability to synchronize after I lose the connectivity and making sure, like for example, if I'm doing a transaction to buy certain things and in the middle, if I lost the connectivity, and as soon as I reconnect it, am I going to issue the same thing again and buy same item twice, or making sure that there was only a single transaction that went through it? So when you do those kind of testing, that's a critical for mobile. Any questions? Okay. So what we'll do is this exercise that we talked about, we'll start doing it from tomorrow and we'll do it whole next week on that one. All right. It's 11:50. So what I want to do is I want to like it still talk the last small piece of module and finish it up more theoretical part so that we can start writing into the test cases starting tomorrow. Okay. So in terms of bringing the laptop tomorrow, if you like, you can bring it. It's not going to be required to bring it tomorrow. Okay. What we're going to do is we're going to write certain scenarios. We're going to start breaking down the process of if somebody gives you a requirement, how you derive what test cases you need to write. And then once you derive the number of test cases you need to write, how do you write step-by-step instruction? So that's what you're going to do. If you bring the laptop, it'll be useful because you can write it on the laptop itself so that whenever we start utilizing the tools, you don't have to type it. You can just do a cut and paste. Okay. But if you don't have the laptop handy, don't need to bring it tomorrow. You can just still write the same thing on a piece of paper and then work through. Okay. But starting tomorrow, you're going to see a shift where, like last week and this week, I've been just talking. Starting tomorrow, it'll be only 10-15 minutes of talking, and it's actually doing the work. Okay. So now let's talk about a defect analysis. So one of the key things as a quality assurance person, you're going to end up is integrating with the defect analysis. So when you're testing it and you find something that doesn't behave as per the requirements, you're going to open a defect. And what is the life cycle of that management? So let's quickly talk about that. Okay. So if you look into the definition, a defect is an error or failure in the computer program or a unintended behavior into the software program. A lot of times it is also talked about as a deviance from the expected behavior. It's about. Most important thing to think about it is if you fail to provide clarity in the requirements, and because of that, the software is behaving a little bit different than what you expected, that's not called a defect. So that's why going back to the 3C and a T, do you really clearly understand what the system is expected to do? If not, you said, hey, this is not the correct requirement. Can you clarify the requirement? That's a really important case because of this thing. Okay. The system, if you don't define the behavior of a system in a certain scenario, you cannot call it as a defect. Okay. So let's talk about what is the normal life cycle looks like. So think about it, you're testing, right? You found something that is not meeting it. So what are you going to do? You're going to first say, hey, this thing is not working as expected. You're going to put out the description that says what you would expect and what it is showing or producing, right? And they're going to essentially let somebody know, right? Either through email or you put in some document, somehow you do it, right? And if you're using formal defect management systems, then you will go and log into that defect. So at that point, you say, hey, I found the defect, now I've opened it. So you entered that information, you shared that information, that somebody needs to fix this problem in the development. At that point, that defect just goes into whoever is performing a development, whether it's an individual or team. They just say, hey, the work that you were doing there is a defect or mismatch in the expectation and the behavior of the system is found. So it gets assigned. Once it gets assigned, the developer initially do an analysis and say, they try to do it, can I reproduce this error in the development environment? And two, is it truly a defect? Or you thought it's a defect, but there was a clarity provided by the business users, and that's how it was implemented. Okay. So they look at it and says, hey, is this really an issue? Or it's not an issue, it's your perceived perception. If it's perceived perception, they will reject it, and the defects will get into rejection state, and then there's no further action needs to be done. But if they look at it and say, yep, you're right, Mr. Tester or Mrs. Tester or Mrs. Tester, this is the problem. You gave me enough information, I can reproduce it. I'm going to go ahead and fix that. So at that point, they will go ahead and write the code, fix it, right? In that pre-scheduled time, they'll give you a new build and flag it and say, hey, you know what, this is fixed. They gave you a new build, but they will change the status in the system that, hey, now this needs to be verified by the testing. You will then again run those test cases and says, did it fix it? If it is, then you're good, and says, okay, now this issue is resolved. If they didn't fix it, they said, well, wait a minute, you did this, but you didn't fix all the issues. You just put a Band-Aid on it. You can't put a Band-Aid. Let me open it again. And it follows the same process. Is it the Band-Aid or not? Okay. So that's kind of common life cycle for a defect. And you continue to that till it gets resolved. Or it gets into a state where it says, we're not going to work on it. So if you're performing a defect management, your first goal as a team, not just the tester, right? Not just a quality assurance, but as a team, your first goal is to prevent the defect from occurring. So you put the procedure or processes in place and say, how do we make sure that the defect doesn't go through it? How do we prevent it from actually happening? That's the integrating quality into the development itself. Okay. However, it's not possible for you to prevent all the defects. So if you're not able to prevent it, then your next goal is, if it is seeped in, let me find as early as possible in the life cycle. Because the sooner I catch the defect, the lesser is the impact, both from a time-wise, as well as from financial point of view. And once I detect it, my goal is to make sure its impact is minimized. Okay. So the whole focus is it's cheaper to prevent it than fix it. Remember the example that I talked about, hey, if I'm fix something at the architecture stage, and it's better than building the whole building and then finding it out and try to fix it. Here is the data from thousands of projects of how much a defect costs in a software world. Okay. So what you're seeing is a typical dollar amount cost, right? So it's like scaled it from 0 to 100. And across the different stages of the software development lifecycle. Okay. So if there is a defect, and if you catch it up in the requirement phase, the cost to fix it is very minimal. Because remember, at this point, nothing is built. It's just the documentation. I just need to sit down with my business users, get clarity, and fix it. Versus it goes into design. Now I may have to redo some work, right? The design work. Still better to catch it up there. Then I catch it up in a code. If it's in a code phase, remember, nothing is messed up, nothing is deployed so far. I was just writing the code. I figured out that, hey, I don't have a clarity on this one. I need to go back to the business users. And that can potentially rework in updating some requirements documents or design documents and me fixing some code. Okay. Then I pass it, I successfully done with the coding, I pass it to the test team and they find the error. Now remember the whole defect life cycle. Now there is more work involved, both from a developer side and from a testing team side. So it's going to cost me more, both time and money. So if I caught something in the requirement phase, I'm going to spend about 10 times more time and money if I catch the same issue all the way into test phase. Then, if the defect migrated into production. So if as a tester, I'm not able to find the defect and it actually goes into production. Now the impact is huge. The reason? Now my data is also corrupted. Because some transaction went through it, which is erroneous. So I have to fix the data. Potentially, I have to compensate my customers, right? So let's take an example. I was doing an e-commerce and my shipment address was wrong. So now I have to get the shipment back from the wrong addresses, give it to the new addresses, and potentially I'm going to lose some customers because A, they said, you can't even figure it out, send me at the right address. Why would I buy things from you? Right? On top of that, if it was certain items and you were legally obligated to provide by that, then you have to provide some compensation for not finishing it that on a time. Then you're going to hit the reputation, right? Because the news is going to be out in the market and people are going to say, oh, you know what? I don't think I want to go to business with this company. I'm going to just do with something else. So you're going to lose potentially new customers. And you still have to go back and fix all those things in your system, right? So you have to do all this work again. And then you have to deploy. Now, also, you can't just deploy on spot instantly, right? So it's going to take you some time to fix it and deploy it. While during that time, you may have to put in some workarounds, right, to deal with that kind of wrong deflection. Or potentially you will continue to let those transactions go at the wrong address, gets corrupted, and then keep continuing paying that till this issue is fixed. So the amount of the money that you end up spending, something goes into production, is typically 100 times more than something that you can catch it in the quality phase. So that's why it's an important for your role as a quality assurance to catch things as early in the cycle as possible. That's where the 3C and a T comes, a really important aspect. But hey, did I catch it at the requirement phase?
Let's keep the, goes back to the business problem where we learned of everything and goes through that chain.
Yes, it has to, right? Because, hey, well, is this truly a business requirement or not? You didn't want it this. You missed it providing this detail, and that's why. Well, let's update the requirement. Let's make sure everybody's in agreement that that's what it should be, and then go through the whole line. So typical, this is the process diagram to manage the defect, right? So we talked about typically you try to do a prevention. That means you have put the process, say, hey, for every requirements document, we're going to go through the sets of review. Well, so that means I have a baseline process that all of the system first must do this requirement, get that approval, make sure there is approval for that. However, something is going to skip through it, right? So they're going to look at it, hey, why did you miss that? What did we do to fix it? And now what can we do to make sure it doesn't happen again, right? And that means I'm going to go back into updating my prevention process and make sure that I create a new baseline. Okay. And throughout, I'm capturing the management reports to figure it out the effectiveness of my defect management process. So you may just start with, hey, we started doing a 3C and a T and we involved the quality assurance people. Guess what? We forgot the architect or technical leads to be involved on also, so that they can identify what additional things they would have needed from the business users. We missed that. Well, because of that, it costs this much rework in this project, or it could cost us this many defects. Well, what kind of changes we can make it? Let's just make sure those guys are involved in every review and they kind of validate it. Let's put the process to say who is going to be playing that role for the next time the system. Make sure it's the consumer. Okay. Now, how I'm going to track it. Okay. So when I do a defect tracking, it's the whole process of managing and tracking it. What happens? What is the life cycle? What are the phases goes? Is a defect tracking. Now, there are tools that is available that you can do it, but you don't have to have a tool, right? You can simply put into Excel or put it into a Word document and keep track that way. That's completely fine. Most of the modern software development tools has a defect tracking, a defect management integrated into it. Whether you think about Jira or when you think about Microsoft DevOps, right? Or you talk about the HP ELM software. All of them has defect management availability. Okay. Now, what kind of information you should capture it in a defect, right? So you are the one who typically, as a quality assurance person or tester, you're opening the defect. So typically you're going to see it in defect and ID, which is typically a lot of times system generated ID if you're using the tools. But more importantly, you're going to describe what the defect is and what type of defect it is. Is it a cosmetic? Is it a database? What type of? You may have different categories defined. And then source of defect. How do you find that defect? Were you doing review and that's when you found the defect? Or you were executing test case and then you found the defect? If so, which test case you were executing, right? So the number of the test cases and so on. We talked about the severity and priority, right? Going from a critical all the way to cosmetic, and priority is high, medium, low based on income. And there is a status. Remember, we went through the life cycle. So where in the life cycle this defect is right now. The timestamp, so you can capture it, certain metrics in terms of how long it takes it for defect to be fixed or how long it takes it to get assigned and so on. Then this is the most important part from a developer's point of view. When somebody opens a defect and writes it that, hey, it was because of this test case, it's nice if you can provide as much information as possible for that defect, including, hey, in which step in the test case you were, what is the screenshot, what is the input you gave it, and what did the system display? Can you do a screenshot of that? So anything that you can provide it in terms of recreating that defect is useful for that. And then they can talk about, hey, which component that you were testing during that time. We talked about screen print and logs, stage of origin. Now, this is important from you to calculate the data. If I find something in development, how much it's costing, or how quickly it gets fixed, versus if something is found in test environment, how long it takes it to fix. Right? So there is some cycle data in the reports and metrics that get generated from that information. You can also see it, who is working on that defect, who is it assigned to. We talked about the priority, like high, medium, low. Which one is the must that I need to update it? Versus which one could be medium and which is the low. Severity. Nothing new. We talked about critical, high, medium, low, and cosmetic. Then you talk about the reports. What kind of reports I can generate from the defect management, right? One is a daily report that you can generate is how many defects created versus how many got fixed, how many are open. So it gives you a good idea and trending is that, hey, am I getting any closer to resolve this to a point where it can be released on time? The distribution. Well, there are 8 components in the systems. Well, where are we finding the difference? What is the distribution? Which area we need to focus more on fixing it? And then detected versus corrected. Here is the sample report. Okay. Now again, in order to fit into one slide, I kind of just showed only a few pieces of data, but defect has a lot more data. You saw it, all the details that we talked about, typically what kind of data you want to capture. But here's an example, right? So here's the ID, but here's the status. One is open, one is assigned, and one is waiting it to be verified because it's already fixed. Then it talks about in which component. Some could be in database, some could be in security, versus some could be in credit application. Then it talks about what is the impact level of that defect and what is the priority, which one needs to be fixed first versus which one needs to do it. So if you look at it, right, security is always going to be critical and most likely high because that exposes you the most. Then when was originally created versus when was last changed, and a little bit high level of summary of what it talks about. Okay. Now, the key thing is when you do an impact analysis, there are a few things which is important. Okay. Once you find the defect, you have to first figure it out. What is the impact of that defect itself? But you also have to look at it as, well, is there a wider impact of the defect, right? So let's take an example of security, right? When you say, hey, the data, when somebody looks at it, right, I don't want to log in, it's not enforcing correct user ID and a password and allowing people to log in. But then they can see it, the data, which is other people's data, non-encrypted. Right? So not only I have to fix this thing, now I have impact of the data could be seen by others. I also need to then worry about, hey, is the data unencrypted? What is the remediation I need to do? So a perfect example, it was not last year, I think its timeline is a little bit blurred for me, but it was not last year, but the year before. One of the 3 credit agencies, Equifax, and above, which kind of opened 360 million people's data, like their email address, their credit status, their passwords, their credit card information, and the security code and the expiry date and all those things were exposed with the birth dates and everything. So somebody could have taken that data and they could have pretended now that to be the other person and did something with that. Right? And impact was 360 million, right? So it was a bug that exposed it. It was a security bug, right? But then I had to do it is what all areas is impacted. It's not just the system. Now the other people has that credentials. They could come and pretend as that other person and still do it. Now I need to have another impact is people could do a fraudulent activity. So I need to go ahead and make sure there is a monitoring put in place. And I can't determine for 360 million people. So I need to give a service that essentially all those 360 million people can use it to determine themselves, is this the transaction they made it or not? Or is this a fraudulent transaction? You see how it was a small bug, but the impact is system impact and outside system impact to the business. You need to do those analyses. It says, in order to fix that mess, how much time we need it. Right? They had to provide people whole 1 year worth of credit monitoring service and how it impacted the financial knowledge. So that's the analysis that you need to do. And that analysis goes in then to make a decision. Is this a critical effect? should it be bumped up to a high priority or not? But it also just tells it, hey, now, if I'm focused on fixing this, that means my time is taken away from doing something else. Right? I might have been doing 500 tests, but this test is so much important that I need to do it. It's going to take me time. And because of that, I cannot test all 500. Now I have to do only 400. Well, what is the impact of business on that? What is the impact on the security and functionality of the systems for not doing that 100 tests? So there's a cascading effect that you need to think about when you do the impact analysis. And typically, you as a quality assurance person is involved in helping the data, but the entire analysis is typically done either by the architects or by the project managers. Okay. Any questions? All right. So what we're going to do is we actually going to stop today for you because I don't want to start a completely new topic in analysis, which is going to get it in much more in depth. So we will start with that first thing in the morning. But what I would recommend all of you is that read the test plan document. And if you get time and opportunity, if you haven't read it anymore, the requirements and specification documents after the discussion on Thursday, I would recommend you to read it at least one more time since Thursday night if possible before tomorrow morning, because we'll start now using those data in some of our discussion, and we'll start going into requirements as how you build the number of test cases from that and how you take one information and take it step-by-step instruction. Okay. And again, as I mentioned, you can bring the laptop if you like it. We can just use that for typing it, but make sure you bring your pen and pencil. Like paper, pen, and pencil. We definitely going to use that tomorrow. Okay. And one thing that I want all of you to be mentally prepared is one of the things you're going to do most when you do the work in a team environment is you're going to share your idea with the rest of the people. That means you're going to be able to comfortable and present what you're thinking to your peers. So as part of the effort and exercise tomorrow, we're going to start doing this. So we're going to have, hey, do your work, come here and explain to everybody else what did you do, why you did that, and what was your thought process. Because part of it is everybody learns from each other's thought process also. Okay. Any questions before I let one of those rare times where you get to go early? Any questions online? Is the silence golden? All right, then please be in around 8:45. We'll start sharp at 9 o'clock. And definitely you don't want to miss any discussion that starts tomorrow. And then Harshal will try to send you guys later today or tomorrow morning the recording of today's session, because it typically takes like 4 or 6 hours for Zoom to tell us that, hey, we're recording.